All right, so we're going to be going over the spring 2016 exam. Literally, this was last semester's exam. And the other thing that I want you guys to focus on is very simply this. How well you would have done on this exam, and then we'll talk about the statistics on how well your compatriots actually did this particular semester. So take a look at this thing. Now remember, I'm going over it with you, so my goal is to make this stuff look trivially easy, but you've got a lot of memorization to do. And remember, also, more than 50% of this exam is going to be focusing on integration and integration techniques. So let's take a look. All right, so part one, right at 3 o'clock, the test booklets are open. It's a no calculator section. Calculators will be put away. The only thing you're allowed to have out there is a pencil. Also, don't forget you got to have your student ID and all these things sitting on the corner of your desk. This is a monitored exam. It is a kind of like the old SAT where you have to open the booklet and then start taking the exam. You'll have an OpScan sheet and a special way to fill that sucker out. And right at 3 o'clock, we open the test booklet. And what a surprise, what's your first problem on the no calculator section? Again, if you try to use a calculator during this particular section of exam, which we've had students in the past try to do that, the exams are ripped up. You make a 0 on that. And if you make a 0 on a final exam that's worth at least 30% of your grade, what is your grade in a semester? You'll be taking this class again, if not completely thrown out of university for cheating. We do that too. So this is no calculator section. We're very serious about this. And then we're going to focus hard on integration skills. Let's take a look at this guy. I want to integrate 7x cubed dx. Traditionally, right from the beginning, we give you a nice, easy problem that kind of ease you guys into this thing. Don't worry, we'll slap you upside the head later. This one's nice and easy. 7x cubed. What is the integral of 7x cubed? Well, 7, integral x cubed, add 1 over add 1, 7x to the 4th over 4. Don't forget your plus c, which is answer which one? D. And then the next one. The integral from 0 to 2 of x times the square root of x squared plus 1 dx. First things first, I don't do square roots. This is the integral of x times x squared plus 1 to the 1/2 power dx. And we got bounds from 0 to 2. Well, don't worry about the bounds. The focus is going to be integration. What technique of integration do I have to use on this guy? U substitution. U would be equal to x squared plus 1. That means du, the derivative is 2x dx, because you took the respective x. I'm going to move my constant to the other side. That makes a 1/2 of du is equal to x dx, which is in the problem. So I know this is a proper u substitution. So when I substitute, this becomes the integral of u to the 1/2. And the x dx turns into a 1/2 du. Half's a constant that goes out front, and we put the du in the back. Okay? Now integrate. Add 1 over add 1. So this will be 1/2 u to the 1/2 plus 1 is 3/2 over 3/2. No plus c's because we got bounds on this thing. So I invert multiply. That'll be 1/2 times invert multiply. That'll be 2/3 u to the 3/2. The 2's end up canceling. So this becomes 1/3 u to the 3/2. But then I got to back substitute. So this is equal to 1/3. What was u? It was x squared plus 1 to the 3/2. Evaluated from 0 to 2. So, according to the fundamental theorem of calculus, we plug in top minus plug in bottom. So this would be equal to 1/3 times 2 squared plus 1 to the 3/2 power minus 1/3 times 0 squared plus 1 to the 3/2 power. Again, no calculator, so look for ways of running the answer that doesn't require kind of computer calculator work here. Let's do some basic math here. 2 squared is 4, plus 1 is 5, so this will be 1/3 5 to the 3/2 power, minus 1/3, and 0 squared is 0, plus 1 is 1, 1 to the 3/2 power, 1 to any power is 1. So I end up getting this. I get 1/3 times 5 to the 3/2 power minus 1/3. Now I'm trying to get this thing to look like one of my answers. They seem to do some factoring. What does these guys have in common? Sorry, they have a third out. Let me get the page so you can see it. So they got 1/3 in common. So when I factor out the 1/3, I'm left with 5 to the 3/2 power minus 1. And there's my answer, which is which one of these guys? Answer is clearly A. Does that make sense? Questions? All right, take a look at the next guy. I want you to integrate 5 cosine 3t plus 3t dt. Now, officially, this is u substitution, but it should be u substitution in your head because we had formulas for quick substitution. The formulas that you are supposed to have memorized are these guys. The integral of the cosine of u du, the integral of the sine of u du, and the integral of integral of kx. These are the ones I want, sorry. This is what u was going to be. Integral of cosine of kx dx, integral of sine of kx dx, and e to the kx dx. These are these fast u substitution integration. What is, hit the wrong button there, sorry. We'll fix this real quick. There we go. Sorry. Too many buttons up here. All right. So, what is the integral of the cosine of kx dx? What was the rule? Well, you integrate cosine, what do you get? Sine. This will be 1 over k sine of kx plus c. What's the integral of sine kx? Negative 1 over k cosine of kx plus c. And what is the integral of e to the kx? 1 over k e to the kx plus c. These were your fast integration rules. Now, officially, if you want to, you can do u substitution, as I wrote it before. U is equal to kx. In each one of these problems, when you do du, it's k dx, and you've got to move the k to the other side. It makes it the 1 over k is where these terms come from. So this problem is actually very quick if you know this answer. So the integral of 5 cosine of 3t dt would be equal to, 5 is a constant, holds over. What's the integral of the cosine of 3t? Well, the cosine of kx is 1 over k sine of kx. So this will be 1 over 3 sine of 3t plus c. So when you clean it up, you end up getting 5/3 the sine of 3t plus c, which is, which answer is this one? Answer is E. Make sure you got these trig formulas memorized, not just sine and cosine, because you know they're going to put every combination of things you have with pluses and minuses on there in terms of multiple choice answers. But also don't forget to integrate the secant squared, the cosecant squared, the secant tangent, so forth and so on. Make sure you got these forms memorized. And don't forget your inverse trig forms too. Lots of memorization for rules here. Next problem. Even though it has bounds, don't worry, they don't simplify them, so they'll put the answer in terms of e or something like that. The integral from 0 to 1 of x squared e to the x cubed plus 1 dx. Clearly this is u substitution. I would let u equal to the exponent, x cubed plus 1. That makes du equal to 3x squared dx. Moving your constant on your standard u substitution to the other side, you get 1/3 du is equal to x squared dx. So when I substitute, this becomes the integral of e to the u, and the x squared dx gets replaced with 1/3 du. The third's a constant, goes up front, the du goes in the back. Another classic rule of memorization, what's the integral of e to the u? So this would be 1/3 e to the u. This thing has bounds, so no plus c on it. So I back substitute. This will be 1/3 e to the u was x cubed plus 1. Okay? And I got bounds. My bounds are from 0 to 1. According to the fundamental theorems, you plug in top minus plug in bottom. This will be 1/3 e to the 1 cubed plus 1 minus 1/3 e to the 0 cubed plus 1. So when you clean this up, you get 1/3 e to the 1 cubed is 1 plus 1 is 2 minus 1/3. 0 cubed is 0 plus 1 is 1. That'll be e to the first. And once again, they did this classic in terms of looking at my answer. They like to factor out that constant out front. And when I factor out that constant, I end up getting 1/3 times e squared minus e to the first is e, which makes the answer clearly going to be which one? B. Does that make sense? But I know you guys are all nervous about a lot of these forms. Take a look at the next guy. You should recognize this. We've done it hundreds of thousands of times. The integration by part problems. When do I use integral of u dv equals uv minus integral of v du? You use this when you end up having, standard formulas. X e to the x, x times sine of x, or x times cosine of x. These are classic problems that you should recognize as integration by parts. And you can anticipate you seeing these guys again. These are pretty common problems we put on exams. So this is a classic integration by parts because u substitution doesn't work. Just to remind you, integration by parts is the integral of u dv equals uv minus the integral of v du. In this particular problem, I'm not worried about the bounds. I'm worried about integrating this integral of the x sine of x dx. I'm going to let u equal to the part I want to get rid of. I don't get rid of the trig. So remember your Lytle principle here. You're always going to let u equal to the part you want to get rid of through the derivative. So therefore, I'm going to let u equal x because when I take derivative of it, I get derivative of x is 1 dx. Therefore, the dv would be equal to a part I can integrate, which will be the sine of x. And when I integrate sine of x, what is the integral of sine of x? Negative cosine of x. Okay? I plug it into my formula over here. U times v, that'll be x times a negative cosine of x, or negative x cosine of x, minus the integral of v, which is a negative cosine of x, du, which is dx. Of course, you want to clean that up. So this is equal to negative x cosine of x plus the integral of the cosine of x. And what is the integral of cosine of x? The integral of cosine of x is sine of x, things we have memorized. And then instead of plus c, once again, they had a lot of one more hoop to jump through with bounds, 0 to 1. But again, it's a no calculator section, so they're going to leave the answer in terms of sines of 1s and cosines of 1 and the like. So fundamental theorem, we plug in top minus plug in bottom. So this would be equal to negative 1 times the sine of 1 plus, oops, I'll miscopy that thing, that's cosine. Negative 1 times the cosine of 1 plus the sine of 1. Fundamental theorem, plug in top, recopy it, plug in top, minus plug in bottom. Negative 0 times the cosine of 0 plus the sine of 0. So this is one of those ways, even though we don't directly ask you what the cosine of special trig functions are, we put them in these problems that we expect you guys to know it so you can clean it up. Now the cosine of 0 is equal to what? 1. But the sine of 0 is equal to 0. And this is 0 times 1, which still makes it 0 plus 0. So this whole part goes to 0. So we end up getting this. Negative the cosine of 1 plus the sine of 1. And so which one is that going to be? Now, again, pay attention to this, because this is where I see a lot of students messing up the exam. I got the right answer. They can't pick it out of the lineup. The reason why is they didn't write it like this because they put the positive dude in the front. So when you put the positive dude in the front, this will be the same thing as the sine of 1 minus, put the negative guy in the back, minus cosine of 1. And then you can see the answer is B. But you will see them take this guy right here and all of a sudden circle the answer E because they weren't paying attention. Pay attention to stuff. Slow it down. Make sure you grab the right answer with this stuff. Does that make sense? Questions? Take a look at the next guy. The integral from 0 to 1, once again, they threw bounds on this stuff, of 4 over u plus 1 du. All right, first thing you got to do is you got to integrate this thing. So if I was going to integrate this guy, it's not a rule I have memorized. I have memorized 1 over u squared plus 1. That's that arctangent stuff. This thing doesn't have a square on it. So I'm going to try u substitution. Well, the problem is I already got u in the problem. So I'm not going to call it u substitution. I'll call it w substitution. I'm going to let w equal to the denominator, u plus 1. Then I use dw, my derivative, which derivative of u plus 1 would be 1 du. And so when I substitute, this turns into the integral. It's a division problem. W is in the denominator. 4 is a constant. It goes out front. And the du turns into a dw. And in your numerator, you always have 1 for placement when you pull everything out. What is the integral of 1 over w dw? 4 natural log officially absolute value of w plus c, but because we have bounds, they're making you jump through one more hoop on this stuff. So you got to go back and back substitute. That'll be 4 natural log absolute value of w, which was u plus 1, and the bounds were from 0 to 1. According to the fundamental theorem of calculus, we plug in top minus plug in bottom. 4 natural log absolute value of 1 plus 1 minus plug in bottom 4 natural log of absolute value of 0 plus 1. Well, when you clean this up, you get 4 natural log of 2, absolute value of 2 is 2, minus 4 natural log absolute value of 1. Absolute value of 1 is 1. One other little thing that you need to know in terms of figuring out your answer, because that answer doesn't seem to be in your lineup, is this. What is the natural log of 1 equal to? Things we know from high school. This is 0, so that goes away. So my answer is going to be 4 natural log of 2, which is clearly answer E. Does that make sense? All right. Occasionally, they're going to sit there and throw a theory question at you. Here's one. Consider the graph of the function f of x. Here is y equals f of x. Here's 0 to 1. Here's 0 to 1. Which of the following statements is correct? The integral from 0 to 1 of f of x dx is greater than 1. The integral from 0 to 1 of f of x dx equals 1. The integral from 0 to 1, 0 is less than the integral from 0 to 1 of f of x dx, which is less than 1/2. 1/2 is less than the integral from 0 to 1 of f of x dx, which is less than 1. And the integral from 0 to 1 of f of x dx equals 0. Well, here's the idea. This is from chapter 5.1. When you're integrating, the geometric representation of the integral is what? The area under the curve. So, when I integrate from 0 to 1 of f of x dx, theoretically, this is what I'm going after. From 0 to 1, here's my graph, just kind of do it up here, and here's the point 1. When I integrate my function, f of x, between 0 and 1, I'm going to get the area under the curve. And because it's bowed out a little bit right here, you know, this is area. The area of the full block is 1. Does that make sense? It's 1 by 1. So the area of the big rectangle is 1. So I can tell you that this integral has to be strictly less than 1 because, you know, the area, if I just make a horizontal line right here, the area of length times width, 1 by 1 is 1. So I know it's less than that. But if I draw a triangle right here, that's 1/2 base times height. The area down here would be a triangle. Area equals 1/2 base, which is 1 times height, which is 1. That's equal to 1/2. And because it's bowed like this, it's a little bit bigger than 1/2. Does that make sense? Based upon the curvature. So even though I don't actually know what the function is, from the theory of me analyzing this thing, I can clearly see the answer is which one? D. So this is how they particularly ask the question, what is the integral from a geometric perspective? Remember, it's the area under the curve. From the curve back to the x-axis. Okay? Try this one. If f is a function satisfying f prime of x equals e to the 3x and f of 0 equals 5, then f of 2 is equal to what? Well, this is actually from the beginning of chapter 5 again. And to basically figure out this guy, here's an idea, and it actually comes from chapter 4.7 from Calculus 1. When I integrate the derivative, I get the original function back, plus c. So here we go. So I'm going to integrate my derivative, which is 6e to the 3x dx. Now, officially, this is u substitution, integrate this thing. But if you got your standard forms memorized, this is one of our fancy forms, the integral e to the kx. Integral e to the kx dx is 1 over k e to the kx. 6 is a constant, leave it alone. Integral e to the 3x is 1 over 3 e to the 3x. Does that make sense? and then I got plus c. So my function, when you clean them up, 6 divided by 3 is 2, e to the 3x plus c. Now, I have this plus c. We need an initial condition to try to figure out what c is. We do this a lot in DFEQ. A lot of you guys are signing up for differential equations next semester. You'll be seeing this kind of stuff again, because when you actually do some integration of these derivatives, you need an initial condition to try to figure out what that c is. So as I know, f of 0 is equal to 5 when I plug it in. F of 0, which will be 2 e to the 3 times 0 plus c, that's got to be equal to 5. Now be careful on this. 3 times 0 is 0, and e to the 0 makes this thing 1, times 2 is 2, so 2 plus c equals 5. Subtract 2 from both sides. This tells me c is actually equal to 3. Does that make sense? Therefore, writing it up here and put my little 3 dots for my answer there, therefore the original function f of x would be equal to 2 e to the 3x plus c, but c is equal to 3. Does that make sense? Now, one more hoop to jump through. What was the question? Oh yeah, we want to figure out what f of 2 is. So f of 2 would be 2e to the 3 times 2 plus 3. And let's see here. 3 times 2 is 6, so this is 2 e to the 6 plus 3. There's my answer, which makes the answer clearly x. Does that make sense? Questions? Number 9. Find the area in the first quadrant bounded by the y-axis and the line y equals 1 and the curve y equals x squared. Here's your chapter 7.1 question. Again, they're asking about area under the curve type thing here. So the first thing I want to do is draw this stuff. You don't need a calculator to draw the basic graphs. X squared, y equals 1, stuff like this. But be careful. Make sure you get the right region. So on this particular problem here, I got the function, I got the y-axis. Okay. So here's the x-axis here. Here's the y-axis, and graphing this guy. I got the y-axis because we're supposed to be in quadrant 1. The line y equals 1. Here is the line y equals 1. And I got the curve y equals x squared. Y equals x squared is the famous parabola. There it is. Y equals x squared. Where is the region? Very important, because if you get the wrong region, there's no way you're going to get the right answer here. Where is the region bounded by these 3 curves? The y-axis, here's my y-axis, I'll bold him. Y equals 1, here's the line y equals 1. And I got y equals x squared, here's y equals x squared, and it did say in the first quadrant, so I'm focusing over here. This is my region. You've got to make sure you get the right region. Does that make sense? How do I find the area between 2 curves? Well, if my function is in terms of x, it is the integral of top minus bottom dx. If my function is in terms of y, it'll be right minus left dy. You remember those things. Again, these are the things why you want to study old exams, to remind you of all these thousands of formulas you have memorized for this class. So here we go. The area would be equal to the integral of top minus bottom, because I'm doing dx on this thing. What's on top of my region is the line y equals 1, minus what's on bottom of my region is the equation y equals x squared. And what are my bounds? Well, this is dx, so clearly I got the y-axis here, which is x is equal to 0. And where does x squared, y equals x squared equal to 1 at? Well, take the square root of both sides. Being in the first quadrant, x is going to be 1. So my bounds are between 0 and 1. Does that make sense? So the integral of 1 minus x squared dx from 0 to 1. Integral of 1 is x minus integral x is x squared is actually x cubed over 3. Evaluated from 0 to 1. These are nice numbers, but fractions are legal. So without a calculator, plug in top minus plug in bottom. This is 1 minus 1 cubed over 3 minus 0 minus 0 cubed over 3, which will be a 0 here. So this is equal to 1 minus a third, which is equal to 2/3 square units. So my answer clearly is E in this problem. Does that make sense? Again, when you're studying for these exams, you need to go through these guys, and don't let this be the only exam you guys do. Go through and not just do the problems, but also kind of have a side little sheet of paper and write down the formulas that was required to do that problem. Top minus bottom dx for area. Now, also, this is free response, which means we don't grade your work, we only grade your answer. All right, all wrong, no partial credit on the multiple choice. Free response, different story. So when I'm doing these problems, I know some shortcuts I can do to this stuff, but I'm also trying to prepare you guys for the final exam. Here's a classic one right here. I want to integrate from 9 to infinity of 1 over t to the 3/2 dt. This is clearly an improper integral. What I call an improper integral type 1, because it's real obvious, you've got an infinity on the bound. Now, you don't have to do all the details, so much details on the limit. You basically integrate, plug in top, plug in bottom. But I'm going to treat this problem as if it was a free response. Because if this was a free response question, this would be the work I want to see. Now remember, it's multiple choice, so you can kind of cut some corners on the thing and make sure you get the right answer, and without writing the limit in great details. But I'm going to go great details on this one. Being an improper integral, this will be equal to the limit, pick my favorite letter, a approaches infinity, of the integral from 9 to a of t to the negative 3/2, go ahead and clean them up, dt. It's still integration. 50% of your exam is going to be integration here. So what's the integral of t to the negative 3/2? We add 1 over add 1. So this will be equal to the limit as a approaches infinity of t to the add 1, negative 1/2, over negative 1/2. No plus c's because I got bounds from 9 to a. This is equal to the limit as a approaches infinity of, invert multiply, that'll be negative 2, divided by, because the negative exponent goes on the bottom, that'll be t to the 1/2, evaluated from 9 to a. And I'm going to go ahead and clean this up just to make it look even better. This will be equal to the limit as a approaches infinity of negative 2 divided by the square root of t, evaluated from 9 to a. According to the fundamental theorem of calculus, we plug in top minus plug in bottom. This will be equal to the limit as a approaches infinity of negative 2 over the square root of a minus negative 2 over the square root of 9. Plug in top minus plug in bottom. Cleaning it up, this will be equal to the limit as a approaches infinity of negative 2 over the square root of a, minus a minus is a plus, 2 over, and the square root of 9 happens to be 3. So I clean it up down here. Notice, proper etiquette. I did limit, all the way up to the point where I plug in the number. Now I've cleaned up all my stuff. Now I'm going to plug in a's going to infinity. And when I plug in the number, I don't write limit anymore. This will be negative 2 over the square root of infinity plus 2/3. The square root of infinity is infinity. 2 divided by infinity, when the infinity is on the bottom, the whole fraction goes to 0. So this is 0 plus 2/3 makes the answer 2/3. The answer is C. Now, being it's free response, did I have to go so much detail on this thing? No. I mean, honestly, most people write limit one time and then they basically integrate the thing, and then at the end, after plug and top, plug and bottom thing, then they actually put the infinity in there and to make it go to 0. You can kind of quote steps on the limit stuff, but if it was free response, you couldn't. You lose points if you did that. So this is what it would look like if it was a free response question. Does that make sense? Look at the next guy. Oh, you know they're going to throw this stuff at you. About 25% is going to be on this series stuff. All right, we got the series here. I got 0.4 plus 0.04 plus 0.004 plus ... You should recognize this type of series. 2 ways you should recognize it. 1, look at it. They've written it out for you. You should recognize this type. But more importantly, look at your answers. Diverges to infinity, diverges but not to infinity. Converges to 4/9, converges to 2/5, and converges to 10/9. There are only 2 different kinds of series. We know exactly what they converge to without much effort. That has got to be either a geometric or a telescoping series. Telescoping series is a fraction minus a fraction where the numerator is going to be the same. That's your standard pattern of it. This one is clearly what? Geometric series. And when you have a geometric series written out, it comes into this form. The sum as n goes from 1 to infinity of a times r to the n minus 1. And just want to remind you that it converges to a over 1 minus r if the absolute value of r is less than 1. And it diverges if the absolute value of r is greater than or equal to 1. Just to remind you of another formula here. This is the traditional chapter 8.2 formula. Now, when you write out a series, it's real easy to figure out who's A and who's R. A is always the number you start with. A is going to be 0.4. R is what I need to multiply by the first term to get to the second term. What do I multiply by 0.4 to get a 0.04? I multiply 0.1. Then I double check myself. What do I multiply by 0.04 to get 0.004? 0.1. So my R is going to be 0.1. When they write out a geometric series, A is always going to be that first term. R is what you multiply the first term to get to the second term, and then you've got to check it to make sure it's the same number I multiply the second term to get to the third term, and then all the way down the line. Now in this problem, my R happens to be 0.1. The absolute value of R, which is still 0.1, is less than 1. So this thing is going to converge to A over 1 minus R, just reminding you of the formula, which will be 0.4 divided by 1 minus 0.1. Oh no, no calculator. Well, don't panic. All right, here we go. This is equal to 0.4 divided by what's 1 minus 0.1? 0.9. Well, how is that going to give you my answer? Well, okay, don't hurt yourselves. Write it as a fraction then. What is 0.4, also known as? 4/10 over what's 0.9? 9/10. And when you divide by a fraction, you invert and multiply. That'll be 4 over 10 divided by 10 over 9, if you think about it. The 10s cancel. Yep, 0.4 over 0.9 is the same thing as 4/9, which means the answer is clearly C. Does that make sense? Questions? All right. Now, again, this is why you study these old final exams. Take a look at this question right here. This series, ready? 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared plus ... What kind of series is this guy? Here's a hint. Positive 1 over 2 squared minus 1 over, positive 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared. What kind of series is it? Alternating series. Recognize this. This is an alternating series. And if you wanted to write out the series, this is the sum as n goes from 1 to infinity of 1 over n squared. Excuse me, negative 1 alternating. Negative 1 to the, let's see here, I want to start out positive, so if I plug in 1, it'll be like n plus 1. This will be what the series is when you write out the formula. Negative, the sum as n goes from 1 to infinity of negative 1 to the n plus 1 over n squared. Just a good practice here. Because when I plug in 1, 1 plus 1 is 2, negative 1 squared is 1 over 1 squared. When I plug in 2, 2 plus 1 is 3, negative 1 cubed is negative 1 over 2 squared. When I plug in 3, 3 plus 1 is 4, negative 1 to the 4th power is positive 1 over n is 3, 3 squared, and it happens to match up to this guy. Okay, plus ... there. Okay? It's an alternating series. So typically we don't tell what alternating series converges to, but that's not quite true. We had this alternating series estimation theorem stuff here. So does this alternating series, does it converge or diverge? Because I got two options. We've got to figure that part out first. So I'm going to use the alternating series test. The Bn part is the part without the alternation, which is 1 over n squared. So two things you got to check. The first thing is write out the terms. N is 1, n is 2, n is 3. That'll be 1 over 1 squared. 1 over 2 squared, which is 4, 1 over 3 squared, which is 9. You notice that the terms are going down. That's a check. Number 2, when I take the limit as n approaches infinity of 1 over n squared, this is 1 over infinity, which goes to 0. The terms go down and the limit goes to 0. What does this mean this thing's going to do? Converges by the alternating series test. What is it actually going to converge to? A number between 0 and a fourth, or a fourth and a half and 3/4, a 3/4 and 1. Well, again, no calculator. So what I'm going to have to do here is basically add up a few of these terms. But remember, the alternating series estimation theorem says that when you just add them up, where the error is going to be always where you stop at the next term up. But I'm just going to add up like the first 3 terms. That'll tell me pretty much what this thing is going to go to. So let's do the first 3 terms. N equals 1, n equals 2, n equals 3. That'll be 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared. Typically, that's good enough. Let's see. 1 over 1 squared, that's pretty much 1 minus 1/4 plus 1/9. Okay? Do some math here. What's 1 minus a fourth? 3/4 plus a 1/9. Okay, you can do common denominators if you really want to, but I don't need to. What is this thing telling me? It's going to converge to what? Look at your answers again. 0 to a fourth to a half to 3/4, and 3/4 to 1. What's this thing going to be converging to? Well, we know that just by the first 2 terms, you're going to 3/4, but the next term up is going to be adding a 1/9 to it, so it's going to be slightly bigger than 3/4, right? Then we take a little bit more to a little bit less away, and then a little bit more, a little bit less, so it's going to be zeroing in on this thing. But when I got the first 2 terms gave me 3/4, and the next term is a 1/9, this is going to be slightly bigger than 3/4, which means it's got to converge to between 3/4 and 1. Using the alternating series estimation theorem and the idea that you can approximate this thing by doing the partial sums. And all I did was the first 3 terms, I did S3, the third 3 partial sums. Does that make sense? Questions? If f of u is equal to the integral from 1 to u of sine of t squared plus 1 dt, then what is f prime of 2? Again, while we practice these old final exams. This right here is what we call the second fundamental theorem of calculus. I think Dr. Stewart calls it the first fundamental theorem of calculus, but who cares? It's one of the fundamental theorem of calculuses. The first one that I know of is when I integrate, I plug in top minus plug in bottom with bounds. The other one is this. I have this function here. F of u is equal to the integral from 1 to u of the sine of t squared plus 1 dt. I want to take the derivative of this guy. To take a derivative, again with respect to u, of the integral from 1 to u of the sine of t squared plus 1 dt, what did the fundamental theorem of calculus say? To take a derivative of an integral, they end up canceling each other out and you don't go anywhere, right? And since the top bound, and this was a u here, sorry, since the top bound was a single variable here, it was u, therefore the derivative and integral cancel, and since I don't have to worry about the chain rule version of this thing, this will be just the sine of u squared plus 1. So that is what the derivative. U prime is, f prime of u, excuse me, is equal to the sine of u squared plus 1. Integral and derivatives cancel. But they want me to find f prime of 2. So one more hoop, plug in 2 into this thing. That'll be the sine of 2 squared plus 1, because all I'm doing is replacing u with 2. 2 squared is 4 plus 1 is 5. This will be the sine of 5. So which one of these answers is it? Answer is A. Does that make sense? Fundamental theorem of calculus, part 1 or 2. Part 1 according to Dr. Stewart. Does that make sense? Take a look at this next guy. Free points. Merry Christmas. As long as you memorize the formula. We told you guys there were, 5 Maclaurin series that you need to have memorized. And we're basically testing you on that. You have it memorized. Here we go. The power series for x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus ... Who is this the power series for? Now, if you needed to, you really could actually go and write down all the power series by doing the derivatives and do the actual Taylor series of these guys, but that just takes way too much time. This is not supposed, you can do it that way, but it's going to take you 15 minutes to find each one of these power series. You should recognize this. What do you notice? These are odd powers. They alternate, and I got factorials on the bottom. Which one is this? Yeah, exactly. That's what this test is all about. The answer is B. This is a 10-second question. Does that make sense? What's the difference between this guy and that old arctangent one down here? You wouldn't have had factorials in the denominator. Things you need to recognize and stuff. If this was even, 1 minus x squared over 2 factorial, that would have been the cosine one because of the even powers. Catch a pattern on these guys. Does that make sense? All right? All right, here we go. Find the power series of sum as n goes from 1 to infinity of 2 to the n times x to the n divided by n squared. Has an interval of convergence. All right. Now, in certain ways, they're going to save me a lot of time if you just pay attention to the answers. All right. Anytime they ask, well, here's a power series, you want interval of convergence, what are you always going to do? Ratio test. Excellent. You've been programmed. Outstanding. Ratio test. Exactly. Ratio test. So, here we go. I'm going to take the limit as n approaches infinity. Again, I will state what you just said. Ratio test. Limit as n approaches infinity of the absolute value of a n plus 1. That'll be 2 to the n plus 1. X to the n plus 1 over n plus 1 squared. Just replace all the n's with n plus 1s. Divided by a n. That'll be 2 to the n, x to the n over n squared. Now I'm going to clean this guy up. I'm going to invert and multiply and go ahead and group together like terms. So this is the limit as n approaches infinity of. This will be 2 to the n plus 1, x to the n plus 1, divided by n plus 1 squared. And when I invert and multiply, that n squared will show up on top. I'll group it together with the other n plus 1 squared. The 2 to the n will show up on bottom, and the x to the n will show up on bottom. Invert and multiply. Now, take a look at these guys. I got 2 to the n plus 1 divided by 2 to the n. One of them has more than the other. Which one has more? Top or bottom? How much more does the top one have than the bottom one? One more. So 2 to the n plus 1, same thing as 2 times 2 to the n. And the 2 to the n's cancel, leaving you with a 2 on top. Same deal with the x to the n plus 1s and the x to the n. X to the n plus 1 is the same thing as x times x to the n, and the x to the n's cancel. So officially, you're left with the limit as n approaches infinity of the absolute value of 2 times x times n over n plus 1 squared. Now, I just did something there just to kind of save myself some time. Both the numerator and the denominator with the n's were squared. N squared divided by n plus 1 squared. Just to clean it up, I factored out the same power because remember, when you do limits, you go after where the n's are at. And I'm looking for this fraction, so I pulled out this squared so my limit can go on the inside. What is the limit as n approaches infinity of n over n plus 1? You either know it or you can actually use L'Hopital's rule, your choice. But derivative of the top is 1, derivative of the bottom is 1. It's 1 over 1, which is 1. So this thing's officially going to go to 1 squared, which is still 1. So you end up getting absolute value of 2x is what this guy is. Now, does that make sense? Because the n's go away when you take your limit as n approaches infinity. This is the ratio test. When does it converge? When whatever's left over has to be what? For a ratio test to converge? Less than 1. This is your classic absolute value inequality, which means negative 1 is less than 2x, which is less than 1. And then I'm going to divide by 2 on both sides. And this is going to give me negative 1/2 is less than x, which is less than 1/2. And here's my answer. And officially, does this make sense so far? This is my almost my interval of convergence. What would the last thing we have to do is check the endpoints when x is equal to a negative 1/2 and x is equal to a 1/2 to see if I want to include these guys or not. But I don't care in this problem. Usually I do, don't get me wrong, I'm trying to show you what to do on free response. But in this problem, I don't care. I don't have to check the endpoints. You know why? They never gave me options on whether the include the endpoints or not. They kind of gave me the hint, but look at this. It's either negative infinity to infinity, well it ain't that, negative 2 to 2, negative 1 to 1, and negative 1/2 to 1/2. They are all including the endpoint, so I assumed, I guess the endpoints work. I don't actually have to show this because I've already got my interval. Which one's it going to be then? D. It's the only one that's going from negative 1/2 to 1/2. They decided to include them, but that's the only answer that fixed this guy. Saves myself some time there. But if it was a free response question, I would have to show the endpoints working. Does that make sense? Questions? Now, I want you to notice something, brother. We started probably after all the big announcements and stuff like that, about 10 minutes after 9 o'clock here. And it is now about 10 minutes till 10. So how long did I spend on this thing? About 35 minutes or so, right? 35, 40 minutes at best. And I gave you guys deep explanation of these problems as I did it. So on the test tomorrow, most people finish up part 1 with about, honestly, 35, 40 minutes is average, okay, for most people finishing up. How long do you have to finish up part 1? 1 hour. You must be finished with part 1 within 1 hour, because you have to turn in part 1 before we allow you guys to use calculator. And it means everybody has to turn in part 1. So you turn in part 1, and then you got your part 2 and your part 3. And part 2 and part 3 are, part 2 is a multiple choice with a calculator. Part 3 is multiple choice with a calculator. But you are not allowed to touch that calculator until everybody in your classroom has turned in part number 1. You will be given your official word of okie dokie. You can use your calculator right now from your professor in your respective classrooms. And once everybody has turned in part 1, up to 1 hour into the exam. So we started the exam at 3 o'clock. Right at 4 o'clock, everyone has to be done with part 1. And maybe these stragglers that want to hold off to everything until the last minute will come up and have to turn it in. And then the professor will say, okay, now you can use your calculator. But you understand, I just done this thing, and I still got about 20 more minutes before I'm officially allowed to use my calculator. Should I just sit there and twiddle my thumbs? Absolutely not. You'll go ahead and get your part 2 out and start working on it. Most of part 2 and the free response won't need a calculator. Only a few problems on the exam will actually need a calculator. So go ahead and finish and go ahead and start to get a problem. And if you run across a problem in part 2 or part 3 that does require a calculator, and I'm not allowed to use my calculator yet, well, that's all right. Just put a big star by the thing and then move on to the next problem and start the next problem. And then when we're allowed to get the calculator, go back and finish the problem up. Okay, let's take a look at this next guy. Part 2 with the calculator, but I won't touch my calculator at least for a while. Most of these problems, I won't need a calculator on. So here we go. A particle is moving along the x-axis. Its velocity at time t equals the square root of t meters per second. How far does it travel from 0 is less than or equal to t, which is less than or equal to 4? All right, so here's my physics problem here. They gave me a velocity function, and I want the distance. Now, officially, you need to know something about this. So you got your velocity function, which is the square root of t. And I'm going to analyze that. And I graph the square root of t, and I notice the square root of t, square root graph, starts at the origin and kind of bows out. Basic graph from high school, you know what it looks like. What you should really be paying attention to is this. It's positive. It does not positive, and then it becomes negative, and then it becomes positive. This thing, quote unquote, not changing direction. What I mean by not changing direction is this. When I graph this particular velocity function, it's always positive, which means it is always going up. Does that make sense? Increasing, if you will. This thing is positive function. So I'm not going positive, then I'm turning around going negative. If the thing dipped down below the x-axis, then I would have a negative region. That means I turn around and went left versus going right type thing, change direction. This thing doesn't have that. So to figure out what your distance is, to get distance, you have to integrate velocity over your bounds a, b, dt. As long as these are going in the same direction. These are going to be positive. We're going between 0 and 4. So this will be the integral from 0 to 4 of officially t to the 1/2 square root of t dt, because it's always positive. Does that make sense? If it, just to let you know, if this thing dipped down below the x-axis, I would separate the above the x-axis region from the below the x-axis region, because below the x-axis would be going in the other direction. And then they're going to ask you a question either about displacement or total distance. Displacement, you want the negatives to cancel with the positive. Total distance, you want to figure out the negative region and make that positive once you get the answer. Take the positive region, and it'll be positive, and then add the two answers together. That'll be the total distance you cover. Displacement, negatives cancel with positive. You just integrate over your region. But this one, it doesn't matter because the entire function is positive. So let's finish this problem up. What's the integral of t to the 1/2? We add 1, that'll be t to the 3/2 over 3/2, evaluated from 0 to 4. I'm going to clean that up. That'll be 2/3 t to the 3/2 evaluated from 0 to 4. This will be 2/3 times 4 to the 3/2 minus 2/3 times 0 to the 3/2. Well, 0 to any power is 0 times 2/3 is still 0. So let's clean this guy up here. What is 4 to the 3/2 power? Well, remember, the fraction of a power is your radical. So what is 3/2? A half on the bottom means square root. What's the square root of 4? Don't hurt yourselves. Don't need a calculator for this. Square root of 4 is 2. Cubed is what? 8. Times 2 is 16/3. And notice they even wrote the answers, and this would obviously be in meters because the velocity was in meters per second. And they even wrote the answer as a fraction, not any crappy decimal anyway, so I really don't need a calculator for this. The answer is clearly E. Does that make sense? And I didn't need a calculator for this. That's my point. All right, go to the next problem. Using the data from problem 1, find the average velocity of a particle between 0 and 1 second. I'm sorry, 0 and 4 seconds, excuse me. This is the key words here. Average velocity. Again, when you're studying these old final exams, what you're really doing is you're going back and looking at formulas you're supposed to have memorized. There was something that we talked about called the average value. Do you remember the average value of a function formula? It's the 1 over b minus a times integral from a to b of f of x dx. This was called the average value of a function. Okay? You know to pull this thing out when you hear the words calculate the average something or other. Okay? So in this case, we want to know the average velocity. So your average velocity is going to be from 0 to 4 would be 1 over 4 minus 0 times integral from 0 to 4 of your velocity, which was the square root of t dt. This was your velocity equation. Does that make sense? That key word in this problem, again, screwed up a lot of people on this one because they didn't know what to do because they weren't thinking in the right mindset. Average value, the value of the function we were playing with in part A was a velocity. So when they were about average velocity, they wanted you to stick this velocity function into your average value formula, which is what I did. And here's the nice thing. I've already integrated this darn thing. What's the integral from 0 to 4 of the square root of t dt? AKA, see last problem. What do we end up getting? 16/3. So I end up having 1/4 times 16/3 because I just did that one. Okay? And then I can clean it up. 4 goes to the 16 4 times. This would be 4/3. And it's the average velocity, and velocity is measured in meters per second. So it's 4/3 meters per second. Answer C. Does that make sense? Questions? Average value, average function, use your average value formula. 1 over b minus a times integral from a to b of f of x dx. Again, what you should be doing as you take these old final exams, and again, don't let this be the only one you do, go through and basically catalog all these special forms that you're using. Yes, ma'am?
Did you know the square root of t like the function because in the question it literally
How do I know the square root of t? Oh, it says this one. Use the data from problem 1. That first part right there. So I'm knowing I'm using this thing here. This is my velocity function here. Does that make sense? Okay. Okay. And basically, and so my answer was this one. So the real hint was just use this answer, and that's really kind of what I was doing there. Does that make sense? Did I lose you guys anywhere? All right. Take a look at the next guy. Number 3. Find the length of the curve. Oh no, more formulas that I have to have memorized. Luckily, I have this one memorized too. Find the length of the curve of y equals 1 minus x to the 4th. For 0 is less than or equal to x, which is less than or equal to 1. Use your calculator to evaluate it. Okay, so this is definitely going to be a calculator kind of a problem here. But, you know, I still got another 5 minutes or 10 minutes before I'm allowed to use a calculator. Don't worry about it. I'm going to set it up, and then I will come back and do the problem. Does that make sense? If I don't have, if I'm still not allowed to use my calculator right now. What you need to know is this, though. Arc length. Do you guys remember the formula? What is it? It is the integral from a to b of the square root of 1 what? Try again. Plus the derivative of your function squared dx. That little sign there means you'll take this class again. All right, so make sure you got these formulas memorized. Arc length is the integral from a to b of the square root of 1 plus the derivative of your function squared dx. Or, I want to remind you, there were actually 3 of them that we went over. This was the big one. The other one's the integral of the square root of 1 plus the derivative of your y function squared dy. And these would be y bounds. And the other one that we actually talked a little bit about, but we're going to set you guys up in Calculus 3 with, is the integral from a to b of the square root of the partial with respect to x, with the derivative of x with respect to t squared plus derivative of y with respect to t squared, called parametric equations dt. We don't typically use that one. We talk a little bit about it, but we wait till Calculus 3 to hit you guys up. But there are actually 2 major formulas in our book that we really want you guys to know about. But then you notice they're basically the same. It's the square root of 1 plus the derivative function squared d, whatever the variable is, from a to b. All right, so here we go. What was my function? Yeah, y was equal to 1 minus x to the 4th. So you got to go back and remember all that stuff you have credit for in your past, called Calculus 1. So what is the derivative? Switch gears, think derivative now. Derivative of 1 is 0, minus derivative of x to the 4th is 4x cubed. So my derivative function is negative 4x cubed. So my arc length would be equal to the integral from 0 to 1, they gave me the bounds here, from 0 to 1, of the square root of 1 plus negative 4x cubed, that quantity, negative 4x cubed quantity, squared dx. All right, because this is going to be a nasty guy, but if you wanted to, you could clean him up. This would be the integral from 0 to 1 of the square root of 1 plus negative 4 squared is actually a positive 16, because when you square a negative, it's positive. X cubed squared is x to the power to a power to multiply. That'll be x to the 6 dx. Now, officially, I may not have the calculator yet, so I would actually stop here, put a big star by this problem, and then flip over to the next problem, but I don't want to wait for the next problem, and so since we're doing the review, I would use the calculator. They even tell me you give me 1 decimal place off the calculator. So here we go. So make sure you bring your calculator, because we are going to ask you some calculator questions on this exam. All right. So here we go. Math number 9. Integral from 0 to 1. Also, if you happen to have trig in these problems, what mode should your calculator in your brain be in? Radian. If you've been taking physics, you may have a lot of stuff in degree mode. Not in a calculus class, not in any math class. You want radians, make sure, because it's sad when the calculator gives you the wrong answer, but you did everything right, you just didn't check the mode on the calculator. Before you walk in on that exam, make sure your calculator is automatically in radian mode. So this is integral from 0 to 1 of the square root of 1 plus, I already hit the square root twice here, sorry for that, delete that one. Square root of 1 plus, and I'm going to show you guys a little trick here. I cleaned this guy up, and that's fine. But personally, I like typing in the original problem because I could have made a careless error somewhere. And so I type in parentheses, negative 4x cubed, that was my derivative, close over arrow, close parentheses squared, so it made it look like the original problem, and then over arrow dx. And I end up getting 1.600229428, which is, they said 1 decimal place. I'm looking for a 1.6 kind of an answer here, which means the answer is clearly E in this problem. Does that make sense? But again, go back and highlight formulas I'm using here. Find the coefficients of x minus 1 cubed in the Taylor expansion of f of x is equal to x to the 7th about a equals 1. Again, this is one of those problems that kind of threw people off, but let's see if we can build this thing up. They want to find the coefficient of the term x minus 1 cubed in the Taylor expansion. So one of the forms you need to have memorized is this, the Taylor polynomial formula, Taylor series. What is Taylor series? F of x is equal to f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial times x minus a cubed plus dot, dot, dot. You have to have this memorized. Very important. Taylor series. Now, here's the deal. Your a is going to be 1. So if you take this formula, your function is going to be f of 1 plus f prime of 1 over 1 factorial times x minus 1 plus f double prime of 1 over 2 factorial times x minus 1 squared plus f triple prime of 1 over 3 factorial times x minus 1 cubed plus dot, dot, dot. What was their question? The question is, what is the coefficient of the x minus 1 cubed term? Do you know what the coefficient of the x minus 1 cubed term is? The coefficient means number out front. It is the f triple prime of a over 3 factorial. Does that make sense? So this is what I have to do. I've got f of x is equal to x to the 7th. I need the the third derivative. All right? So f prime of x would be 7x to the 6th. F second derivative would be what? 6 times 7, which is what? 42. X to the 5th. And then my third derivative would be 42 times 5. Yep, time for the calculator now. 42 times 5, which is 210. X to the 4th. There's my second derivative. But remember, you got to plug in 1. So f triple prime of 1 would be 210 times 1 to the 4th. 1 to the 4th is 1. This is 210. So, bum, 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 your coefficient is going to be f triple prime of 1 divided by 3 factorial. This would be, so coefficient is going to be 210 divided by 3 factorial. This is 210 divided by 6, because 3 factorial is 3 times 2 times 1, which is 6. And 210 divided by 6 is 35. Does that make sense? So clearly the answer is D. Again, this is not like a problem you may have seen before, but you should have been able to figure it out if you know what the Taylor polynomial formula is, Taylor series formula, how it's written out, and then just going by and just analyzing and answering their questions, because it's really not that difficult. Does that make sense? Questions? Question? Okay. Take a look at this guy here. Find the volume formed by when the region bounded by the curve y equals e to the x, and below the x-axis between 0 is less or equal to x, which is less or equal to 1, is rotated about the x-axis. Answer to 2 decimal places. So you can see lots of calculator on this thing. And by now, I'm definitely in the calculator mode in terms of my test now. So here we go. All right, first things first, I want to graph this guy. Find the volume of the solid formed by when the region bounded by the curves of y equals e to the x. Y equals e to the x looks like this. It's a classic exponential function. Things we know from high school. Here's y equals e to the x. Bounded below by the x-axis. This is on top. The x-axis. This is on bottom. Bounded above, bounded below, between 0 and 1. Well, here's clearly 0, and I will declare this number to be 1 right here. X equals 0, x equals 1. We're talking about this region right here. Most important, listen to my words. What variable is my region, my functions in terms of, that bound my region? What variable is this thing in terms of? X. What axis do I want to rotate around? X. We're going to rotate about the x-axis. The function is in terms of x, and we want to rotate around the x-axis. What method will I use? Disk washer method. Very good. Disk washer method. Functions in terms of x, rotating around the x, disk washer method. Functions in terms of x, rotating around the y-axis, or something parallel to the y-axis, shell method. When the variable of the function is the same as the variable of the axis, or parallel to that axis, it's the disk washer method. When the variable of the function that defines your region is opposite of the axis, you're going to use the shell method. That is the pattern. So make sure you have the two forms memorized. And just for your benefit, the formula for the disk washer volume is equal to pi times integral from a to b of your big radius, functional radius squared minus little functional radius squared dx. This is the disk washer method. Okay? Just a little side note down here. What was the shell method when your function is in terms of, let's say, x, and you want to rotate around the y or parallel to the y-axis? What was that formula? Volume is equal to 2 pi times integral of what I call the point radius times f of x top minus g of x bottom dx. Just want to remind you from A to B there what the formulas are, because you never know which one you're going to have to pull out and use. This one, because my function is in terms of x, and I'm rotating around the x-axis, this is a disk washer formula. So you got to figure out what your big radius is going to be. My big radius is from the axis of rotation to the outside edge of my region as part of your function as you envision this thing being rotated, and it's a distance, top minus bottom. This would be e to the x minus top minus bottom 0. That gives you e to the x. The little radius is from the axis of rotation to the inside edge. But because when you envision this thing is solid, the little radius actually would be 0, because this is actually what we call the disk method. Okay, there's no little open circle inside this thing when you rotate it. Okay? So my volume is going to be equal to pi times the integral from my bounds 0 to 1 of the big radius, which is my big radius is e to the x, squared minus the little radius, which is 0 squared dx. Now, I can stick this on the calculator at this point, and if they don't care, I strongly recommend that because I don't want to make careless errors. But sometimes people want to clean this up, and I perfectly agree with knowing how to clean it up. This would be volume equals pi times integral from 0 to 1 of the integral e to the x quantity squared, power to a power I multiply. This is the same thing as e to the 2x minus 0 squared. That's pretty much 0 dx. And you can integrate this thing by hand. The integral e to the 2x is 1/2 e to the 2x. Evaluate from plug in top 1 minus plug in bottom 0, crunch it out, and then don't forget to multiply your answer by pi. But this one, when they're talking about rounding your answer and stuff, let's go ahead and use our calculator on this thing just to make sure we don't mess it up. So this would be pi times the math integral, math number 9, pi times integral from 0 to 1 of e to the 2x dx. What did I end up getting on this one? I got 10.0359, and I'll write out all that stuff. 10.03590585. Okay? And so they want this thing round to 2 decimal places. So the 2 decimal places here, this thing would be what? 10.04 units cubed because it's volume, which means the answer is which one? Okay. Does that make sense? Again, reminding you of all the formulas you need to know. Take a look at this guy. Consider the function, consider the following table for values of a certain function. So I've got here x is equal to 0, 1/2, 1, 3/2, and 2, and f of x is 1, negative 2, 2, 4, negative 4. So, and for example, f of 1 equals 2. There you go. Find the Riemann sum on the interval from 0 to 2 using n equals 4 subintervals. We know, and you should double check this, you have your program on your calculator, your Riemann sum program. How can we mess you up by not really allowing you to use that thing? Because if I got a Riemann sum program, I can do any Riemann sum and get the right answer. Well, we can do this by giving you a chart instead of giving you a function. Because this means I actually have to have the formula memorized. What is your Riemann sum formula? Okay. Now, what are they asking for? They want you to do this. With equal lengths, taking sample points to be the left endpoints of the subintervals. They want a left Riemann sum. Just to remind you, your left Riemann sum is the sum of f of xi times delta x. Okay? This would be equal to, officially, delta x times f of a plus f of x1 plus f of x2 dot 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 plus f of xn minus 1, because you're using the points on the left. Left points. So you're always going to stop short of being the b number there. So in this example here, what is my delta x? The formula for delta x is b minus a divided by n. My a and b, a is equal to 0, b is equal to 2, so this will be 2 minus 0 divided by n is equal to 4. So, what a surprise, 2 minus 0 is 0, 2 minus 0 is 2, divided by 4 is 1/2. My delta x is 1/2. And they gave me the partition points for 1/2. So, my left Riemann sum, and this is for your benefit for 4 partitions here, would be your delta x, which is 1/2, times f of, the point on the left is 0, plus f of, on the next partition between 0 and 1/2, point on the left is 0, between 1/2 and 1, the point on the left is 1/2, plus f between 1/2 and 1, the point on the left, between 1 and 3/2, the point on the left is 1, plus between 3/2 and 2, the point on the left is 3/2, f of 3/2. So you got partitions, 0 to 1/2, point on the left is 0. Between 1/2 and 1, point on the left is 1/2. Between 1 and 3/2, point on the left is 1. Between 3/2 and 2, the point on the left is 3/2. But they gave me the table for these things. So this would be equal to 1/2 times f of 0, which is 1, plus f of 1/2, which is -2, plus f of 1, which is 2, plus f of 3/2 is 4. Well, I don't think I need a calculator for this. -2 plus 2 pretty much cancel. 1 plus 4 is 5 times 1/2 is 5/2. So the answer clearly is C. Don't forget your left, your right, Riemann sums, the midpoint Riemann sum, the formula for trapezoid Riemann sum, and the formula for Simpson's rule Riemann sum. Okay. So go back and make sure on your study notes you write these things down and make sure you get them memorized, because I have no idea which question they're going to ask you on tomorrow's exam. All right, take a look at this guy. A 120-pound woman with a bag of sand on her back climbs up a rope as part of a military exercise. The bag weighs 50 pounds as she begins to climb. However, the bag has a small hole in it, which causes it to leak at a constant rate of 2 pounds per foot as she climbs. How much work does she do if she climbs 25 feet? All right, here we go. First things first, we're focusing on work. There are 2 situations going on here, so you've got to analyze both situations. Work total. 2 things going on here. You got the work on the woman herself, plus you got the work on her back. Okay? The easy one would be the work on the woman. Work is straight line basic formula, force times distance. Okay? Force times distance. What is her force? Let's take a look at it. All right, a 120-pound woman is walking up this 25-foot climb here, right, up a cliff. She weighs 120 pounds. That's her force, 120 pounds. How far is she going? Times 25 feet. Force times distance, because her weight doesn't change and the distance is basically 25 feet. Force times distance. So 120 times 25 is 3,000 foot-pounds. Does that make sense? That's straight up the work on the woman. Now we got to worry about the work on the bag. The work on the bag, see, here's my problem. The force on the bag is changing. What's going on with the bag? The bag weighs 50 pounds as she begins to climb. Because of the small hole, it begins to leak at a rate of 2 pounds per foot. So let's talk about the force on the bag. How much does it weigh? It weighs 50 pounds. But because of that hole, we're going to take away what? 2 pounds per foot, And how far is she going? This is going to be a variable. She's going to go t feet, because this is now going to be a function. Depends on how far she goes, how much sand she's going to end up losing. Does that make sense? And then eventually how much the bag weighs. So to truly understand this, at the beginning it's going to weigh 50 pounds. After 25 feet, how much does the bag weigh? She's losing, like I said, 2 pounds per foot. She goes 25 feet. How much has she lost? Well, 50 pounds. It weighed 50 pounds, so guess what? By the time she's done, it must be air, because it's not going to weigh anything at all. Does that make sense? Because she keeps losing it. So you had to write a function for this. And to remind you, this is your straight line formula, work equals force times distance. The other formula for work is the integral of force dx, or in this case dt, because t being feet. I could also call this dx if you want to, because you guys used to t being time. So we'll call this dx for x is the number of feet. Okay, so we'll use x variable for x for distance. Okay, so integral f dx, and your force in the bag will be 50 pounds minus 2 pounds per foot times x feet. So this would be equal to the integral, from a to b there, from 0 to 25 of 50 minus 2x dx. Does that make sense? Well, I integrate this guy. This would be equal to 50x minus x squared, evaluated from 0 to 25. Fundamental theorem of calculus, plug in top minus plug in bottom. 50 times 25 minus 25 squared. Plug in top minus plug in bottom. That's kind of nice, because you plug in 0, pretty much you get 0. So I'll just put that on the old handy dandy calculator here. 50 times 25 minus 25 squared is 625 foot-pounds. Does that ring a bell and make sense? Classic chapter 7.5 material here. But remember what the question is. The question is, what is the work total? Well, you had to take the work on the woman. That was 3,000 foot-pounds, plus the work on the bag, which is 625 foot-pounds, makes a grand total of 3,625 foot-pounds, which makes the answer C. Did I lose you guys anywhere? Does that make sense? Again, reminding you of some classic formulas from Chapter 7. Speaking of Chapter 7, let's try this problem. Find the area of the finite region in the first quadrant bounded by the curves y equals x to the fourth and y equals 2 minus x. Area between two curves. Top minus bottom dx, right minus left dy. These functions are in terms of x. So I want to graph this thing. So here we go. I got y equals x to the fourth. If you graph y equals x to the fourth, it looks like a parabola, but it's a little flatter on the bottom and then goes back up again. So this is the graph of y equals x to the fourth. Y equals 2 minus x. Y equals 2 minus x is a line that comes down here, hits the y-axis 2, and has a slope of -1, down 1 over 1. And you can put this on the calculator if you're not real comfortable with this, but these are basic functions, so you should. So what does it say? Find the area of the finite region in the first quadrant. So first quadrant, so I only care about is x here, in the first quadrant bounded by these two curves. So they're talking about this region here because of that first quadrant they're interested in. The next thing I got to have is, well, I clearly from the picture can see which function's on top versus which function's on the bottom. Okay, so based upon that, I just got to figure out that point of intersection. What is that point of intersection going to end up being? Well, so here we go. Y equals x to the fourth, and y equals 2 minus x. So what point will these things actually meet up at? Well, it should be kind of obvious, but in case you don't know, we can use our calculator on this thing. So this is y equals, clear this thing out, y equals x to the fourth, and y equals 2 minus x, 2 minus x, and I can do the old zoom 6 on it, zoom 6, standard. And here's my region, and you can see it. And here comes the other line. And I'm going to blow it up right here, zoom in right here at the origin. So you can see this line coming in here, a little flatter and coming in. And I want that point of intersection. Second, calculate intersection, first curve, second curve, and I guess it right about there. But if I look at this thing, it looks like they're going to meet up at 1, which clearly is the case. It's the point 1, 1 where they meet up at. Okay? So this is the point 1, 1 here. Does that make sense? So area is going to be equal to the integral of top, which is 2 minus x, minus bottom, which is x to the 4th dx, evaluated from 0 to 1. So let's integrate this thing. So the integral of 2 with respect to x is going to be 2x, minus the integral of x is going to be x squared over 2, minus the integral of x to the 4th is x to the 5th over 5, evaluated from 0 to 1. Remember, this is classic top minus bottom dx here, so just trying to remind you of the formulas. Okay? Plug in top minus plug in bottom, fundamental theorem of calculus. This will be 2 times 1 minus 1 squared over 2 minus 1 to the 5th over 5. Minus plug in 0, I get 0. So pretty much this is going to be what? 2 minus 1/2 minus 1/5. So second quit on the old calculator there. 2 minus 1/2 minus 1/5, fifth, is equal to, I got 1.3. So the answer clearly is B. Does that make sense? Question? Yeah.
Do we always do top minus bottom in the area?
Top minus bottom when it's dx, when you have functions that are in terms of x, or it's right minus left when the variable is in terms of y. That'll be dy. Yes. Other questions? Does this make sense? All right. Take a look at the next guy. Number 9. Here's a classic problem that you no doubt seen before, like 2 days ago. Here it is. Which of the following series converges? The sum as n goes from 1 to infinity of negative 1 to the n over n plus 1. The sum as n goes from 0 to infinity of 3n plus 5 over n plus 7. And number 3, the sum as n goes from 0 to infinity of n plus 100 over n cubed plus 1. All right. Now, the ultimate goal here is to get these things done quickly. So you should be able to see these guys and see exactly what they are. But I'm going to talk about each one individually so you make sure just remind some series information here. Well, let's focus on number 1. All right. This is the sum as n goes from 0 to infinity of negative 1 to the n over n plus 1. What kind of series is this guy? Alternating series. So to test it out, I'm going to use the alternating series test. The Bn part, the part without the alternation, is 1 over n plus 1. You got to write out the terms. This thing starts at 0. So that's 0, 1, 2. Plug in 0, 1, 0 plus 1 is 1. 1 over 1 is 1. Plug in 1, I get a half. Plug in 2, I get a third. Yep. The terms are going down. And number 2, when I take my limit as n approaches infinity of 1 over n plus 1, the sequence part of your series without the alternation, I get 1 over infinity plus 1 is infinity, and 1 over infinity is 0. The terms go down, and the limit goes to 0. What is this thing going to do by the alternating series test? Converges, which means I want this guy. So let's take a look at number 2 then. The sum as n goes from 0 to infinity of 3n plus 5 over n plus 7. This is something you just have to train yourself for. Look at the series, the sequence part of your series. 3n plus 5 over n plus 7. I happen to notice the degree of the top is the same as the degree of the bottom. I got an n on top, I got n on the bottom. Does that make sense? We have something called the divergence test, which says very simply this. If you got a series, and if you take the limit as n approaches infinity of the sequence part of your series, and you don't get 0, automatically the series is going to diverge. This is called the divergence test. It's one of those 7 tests you have memorized. So by the divergence test, because the limit as n approaches infinity of 3n plus 5 over n plus 7, well, you can do L'Hopital's rule on this one, or degree of the top, degree of the bottom is the same, so the answer is going to be the ratio of leading coefficient. What do you end up getting on this, regardless? I'm going to get 3, officially 3 over 1, right? I get 3, which is not 0. So by the divergence test, this thing is going to diverge. Does that make sense? Which means this thing is completely out. Do not want number 2. That thing's going to diverge by the divergence test. Number 3. Look at this guy. The sum as n goes from 0 to infinity of n plus 100 over n cubed plus 1. Now, this is one that, okay, I would do a comparison test on. And when I'm doing a comparison, what is this thing going to look like? Adding numbers to this thing in the numerator and denominator, overall effect was not going to affect it. You got to focus on the degree terms. So this thing, and I put a little squiggly equal to, this is approximately the same thing as the sum of n over n cubed. Does that make sense? Because you're focusing on the degree terms. And what is n over n cubed equal to? When you clean it up. This is the sum of 1 over n squared. This guy is approximately this guy. Does that make sense? In terms of comparisons. Just trying to figure out who to compare to. Now, who is this dude? What's his name? P series. What's P equal to? 2. What's it do? Since that's bigger than 1, it's going to converge. So automatically in my mind, I know this thing's going to converge. Actually, to prove it's going to converge, I'll do the limit comparison test. And I'll take the limit as n approaches infinity of the sequence part of the unknown, n plus 100 over n cubed plus 1, divided by the known series of 1 over n squared. And as long as I get a number that's not 0, not infinity, these two guys do the same thing. So when I clean this up, this will be the limit as n approaches infinity of n plus 100 over n cubed plus 1. Invert and multiply, it'll be n squared over 1 on top. And when I distribute these guys, I get the limit as n approaches infinity of n cubed plus 100n over n cubed plus 1. And the degree of the top equals degree of the bottom, so I'm going to end up getting 1 when I do my limit. You can do L'Hopital's rule on it or whatever you want, but it's the degree of the top, degree of the bottom are the same. Now, your question may be, well, this guy started at 0. This one would probably start at 1, but it's going to be the same thing. You can shift them off by a little bit, but the fact of the matter is that when you're doing these comparison series, know what to compare to. Focus on the degree terms, especially on these almost P series, comparing it to a P series, so you can figure out exactly what P series is going to work like. Question? Yeah?
If we do our regular comparison test, do we have to follow up with the limit comparison test afterward, or can we have stopped?
With this being a multiple choice problem, you could have stopped. And going, hey, this is going to basically do the same thing as 1 over n squared, which I know converges, so this thing converges, so I want this guy. So the answer is going to be 1 and 3. So the answer is clearly going to be A here. However, every time I'm doing these problems, I'm trying to do a review. So I'm going into greater detail than what you have to show in the multiple choice, because what if this problem was a free response question? Then this is what we would want to see. Does that make sense? But here's the deal. This is going to be 1 and 3 is going to be what it converges to. Yes, ma'am. When do I know when to use the divergence test? When I look at a series and I see that the top, when I have a classic fraction of the sequence part of a series, and I see that mentally in my head, when the top is greater than or equal to the bottom in terms of the degree or powers or whatever, I know I'm going to use the divergence test. Because when I take the limit as n approaches infinity of this guy right here, of 3n plus 5 over n plus 7, I know because degree of the top equals degree of the bottom, I'm going to get 3. In any series, if it even has a chance of converging, the fact of the matter is the bottom has always got to be bigger. When the top is the same or bigger than the bottom, when the numerator has a power of the same or greater than that of the denominator, it's always going to diverge, and the divergence test tells me that. So it's something you train yourself for, to look for. The bottom has always got to be bigger. In this problem, bottom is bigger. In this problem, bottom's bigger. This one's not. It's going to diverge. Does that make sense? Oh, partial fractions. Yay, you know you're going to get one of these problems on the test. All right. Find B in the partial fraction decomposition of 3x plus 1 over x times x minus 1 equals a over x plus b over x minus 1. Remember, in your partial fraction decomposition, it's got to be a proper fraction. Degree of the top's got to be less than degree of the bottom. When you FOIL this out, this is x squared minus x. And the denominator factors. These are your two keys here. So the first thing I'm going to do is multiply both sides by my common denominator, which is x times x minus 1. I'm going to clear denominators. Over here on the left side, that is the common denominator, so it completely cancels. That leaves me with 3x plus 1 equals. Now I'm going to distribute this thing throughout. A over x times x minus 1. The x's cancel. I'm left with a times x minus 1 plus b. Here, when I multiply b over x minus 1 times x minus 1, I'm left with just bx. Now here's a trick for you. Now traditionally I solve for a and b on these guys, so typically I'm going to use what? What we call the annihilator method, the guy that kills off these terms. I would use x is equal to what two numbers here? What numbers would I use? 1 and 0. Now, here's my question. They didn't ask me to find both these two guys. They just wanted me to find b. Which one kills off a? What x number, when I plug it into this thing, is going to kill off a so I can solve for b? 1. When I plug in 1, 1 minus 1 is 0. It will kill off a. So actually, I don't have to do both of these guys. This is the only guy I really have to use. Does that make sense? Plug in 1. This will be 3 times 1 plus 1 is equal to a times 1 minus 1 plus b times 1. This 3 times 1 is 3 plus 1 is 4 equals a times 1 minus 1 is 0 plus b times 1 is b. A times 0 is 0. That goes away. So b has got to be equal to 4. And this was a very quick problem once you actually know how to do it. Does that make sense? So this was kind of short because usually they'll ask for what is a and b. In that case, I'm half done. Then I go back and plug in 0 and get the other dude. Oh, back to a series question again. Consider the series, the sum as n goes from 1 to infinity of the natural log of n over n. Which of the following results in a successful determination of a convergence or divergence of series? This is one of the classic kind of problems they're going to put on the final exam, where you actually, instead of just doing the problem and then picking out the answer, you actually have to analyze the answer to figure out which one's going to work. It's one of those kind of questions. So let's look at our series. This is the sum of n goes from 1 to infinity of the natural log of n over n. Now, which guys would you use on this thing? Would you ever use the ratio test on this thing? Lord, no. When do you use the ratio test? What two situations? Powers of n and or factorials. You gain powers of n on this thing or factorials? Nope, sure don't. So that would be stupid. Don't use ratio test on this one. That's not the answer. Let's keep on going. Would you use the divergence test? Well, if I do the divergence test, basically take the limit as n approaches infinity of the sequence part. Well, what happens when you do that? Limit as n approaches infinity of the natural log of n over n. Just wanted to show you guys. Well, it gives you infinity over infinity, which means I actually really do have to use L'Hopital's rule. This will be the limit as n approaches infinity of, here we go, derivative of the top, derivative of natural log of n is 1 over n, and the derivative of n is 1. When I plug in my infinity, this gives you 1 over infinity, which is 0, which tells me nothing. Because the divergence test says if you get some other number than 0, you can't get 0, then the series is going to diverge. But if you get 0, divergence test doesn't tell you anything. So divergence test does not work because the bottom really is bigger than the top in the concept of things. Okay? So let's go this. All right, take a look next guy. Comparison with the terms of the series, the sum as n goes from 1 to infinity of 1 over n squared. Look at your original series. What do you got? I got comparing it to the sum as n goes from 1 to infinity of the natural log of n over n. They want to compare it to 1 over n squared. Now, I'm not going to argue about comparison tests, but I'm arguing this. This is the wrong dude to compare to. Why is it the wrong dude to compare to? What is the degree of the n in the original series we're looking for? Understood to be 1. What are they trying to compare it to it? A p series is p equals 2. Now, comparison I may go with, but I would try to compare it to like a harmonic or something or other, because that's what the n is in the denominator. It's 1 over n style. Does that make sense? N squared, that's just bad because you got the wrong dude to compare it to. Does that make sense? It's got to be close. N squared is not close to n to the first power. Okay? So, what else? What about the integral test? Can you integrate this guy is the question. Well, using the integral test, The sum as n goes from 1 to infinity of the natural log of n over n. This would be equal to summation turns into integration when we do the approximation by the integral test of the natural log of x over x dx. And we're integrating it from 1 to infinity. Now, if you really want to practice your integral skills, this is a review for the exam, so personally I would cut corners on this, but this is for your benefit. This will be the limit as a approaches infinity of the integral from 1 to a of the natural log of x over x dx. What technique of integration would you use to integrate this fine integral? Use substitution. You would let u equal to the natural log of x, which means du equals 1 over x dx, which is in the problem. So this thing turns into the integral of u du, which gives you u squared over 2, which converts back to the natural log of x squared over 2. And now you're going to take your limit as a approaches infinity from 1 to a of your bounds there. Fundamental theorem of calculus, plug in top minus plug in bottom. So this is equal to the limit as a approaches infinity of the natural log of a squared over 2 minus the natural log of 1 squared over 2. Well, what's the natural log of 1 again? Natural log of 1 is equal to what? 0, things we know from high school. So this is 0. So this is equal to the limit as a approaches infinity of the natural log of a over 2. Natural log of a squared over 2. Plug in infinity. This is natural log of infinity squared over 2. But from calculus 1, what is the natural log of infinity? Natural log of infinity is infinity. This will be infinity squared over 2. Infinity squared is infinity divided by 2 is infinity. So the integral diverges. What does that mean about the series? Therefore, the series is going to diverge by the integral test. This does tell me this thing is going to diverge. So this is actually my answer, because this guy actually works. Does that make sense? Question?
Could we not, because several of those tests we can kind of analyze and say that's not going to work, that won't work. Once we hear it down, can we just say, oh, then it has to be the
Yes, on a multiple choice. But if this was a free response question, which I'm trying to always approach every question, what would you have to do to see a free response? To make sure you maximize your point total, I have to show all this work. And that's why I did this. But, all right, you're right. I could have said, okay, just like I did here. Bad, bad, bad. Now look at E down here. The alternating series test. Well, this is pretty much stupid because what's the problem? The natural log, the sum as n goes from 1 to infinity of natural log of n over n. You see -1 to the n's or the worst case cosine of pi n type thing here. Is this thing alternating? No. Well, then I should not use the alternating series test, so that would be stupid. So in that case, the process of elimination would say the answer has to be D. But I was just doing one at a time, and I actually wanted to show you what an integral test appropriately applied would look like. Again, reviewing for the final exam here. All right, take a look at this guy here. I put this guy on my kid's test, my student's test this, 2 days ago. Here it is. Find the integral of convergence for the power series. The sum as n goes from 0 to infinity of 5 to the n times x to the n over n factorial. Because it is a easy question if you actually paid attention to all the lectures I've been doing with you guys. What's the answer? What's the interval of convergence? A. Why? Factorial on bottom always converges. Factorial on top almost always diverges, except for that one point that makes up 0. So power, catch power on the factorials. When the factorial is in the denominator, you're going to get a series that always converges. When you get a factorial on top, you're going to get a series that almost always diverges. There's always at least one point of convergence. That's the 0 point that makes the series add up zeros. But that being the case, here's the deal. If I wanted to prove this to you because it was on the free response part of a test, what test would I have to use? This would prove by the ratio test. And so I would show you by taking the limit as n approaches infinity of the absolute value of 5 to the n plus 1, x to the n plus 1 over n plus 1 factorial divided by 5 to the n, x to the n over n factorial. Invert, multiply, clean it up. This would be equal to the limit as n approaches infinity of the absolute value of 5 to the n plus 1 times x to the n plus 1 divided by n plus 1 factorial. Invert multiply, I got an n factorial on top, a 5 to the n on the bottom, and x to the n on the bottom. Remember, your powers of n and your factorials are always going to cancel. In this thing, let me show you the powers of n canceling. 5 to the n plus 1 is the same thing as 5 to the n times 5. So the 5 to the n's cancel, leaving you with a 5 on top. X to the n plus 1 is x times x to the n, and the x to the n's cancel, leaving you with x on top. So this is equal to the limit as n approaches infinity of the absolute value of 5 times x times n factorial over n plus 1 factorial. Now, to deal with your factorials, what you have to do is this. Write out the definition. N factorial by definition is n times n minus 1 all the way down to 1. N plus 1 factorial is n plus 1 times n minus 1 all the way down to 1. The n's all the way down to 1 cancel, but with the factorials you're left with an n term left over. Does that make sense? So these guys almost cancel except with an extra n plus 1 left over. So you're left with the limit as the n approaches infinity of the absolute value of 5x over n plus 1. Remember, 5 is a constant, don't worry about it. X is a variable, but it represents a constant, don't worry about it. You're taking the limit as n approaches infinity. When I take the limit as n approaches infinity, this will be equal to 5x divided by infinity. And when you have an infinity on the bottom, what is my overall fraction going to go to? 0. And to remind you, this is the ratio test. So because that limit is n approaches infinity, all my variables end up canceling out, so I don't have anything left over except 0. And in the ratio test, you compare to 1. How does 0 compare to 1? 0 is less than 1, which implies converging always. Being always, that means for any variable, any x being between negative infinity to infinity, that is why the answer is negative infinity to infinity. This will always happen if you catch a pattern when the factorial is on the bottom. It'll be all real numbers. If the factorial would happen to be on top, you know what your interval of convergence is? You wouldn't have one. X would be equal to 0 would be your point of convergence, because that would be the only point that I would add up a bunch of zeros to get 0, and that does converge. But any other thing you plug in here would actually diverge. You always have at least one point of convergence with any series. Does that make sense? Okay. Well, and also notice this. Lots of folks look at these, look at the multiple choice sections, part A and part B. We always ask around 25 to 30 questions each semester. Every semester they differ, but I guarantee you this. The number of questions in part 1 multiple choice will be different than the number of questions in part 2. And the reason for that is, in case one of your OpScan sheets falls on the ground, we can look at how many questions you bubbled in to figure out if it was a part 1 question or a part 2 question. So we make sure these guys get in the right pile. So they'll always be different. On the last one, you notice we only had, 12 multiple choice questions with the calculator. We had, a lot more than that on the first one, whatever that was. The first one was, how many questions we end up having? 15 questions? Let's see, 15 questions. So grand total, you had 27 questions. Like I said, it's always somewhere between 25 and 30. Each semester, they'll differ it up by a little bit. Does that make sense? Now, each question I've done for you guys this morning has been one problem that I could have done a lot more shortcutting it because it was free response, multiple choice. And that's okay, multiple choice, because we don't really pay attention to your work. But free response is a different monster altogether. You are supposed to show your work, and you've got to impress your professors, okay? So, go in great detail on showing your work. Because I've had many a time I've seen the correct answer on a final exam paper, but there was no supporting work to show how they got this answer, and out of a 10-point problem, you know how many points I got? Minus 15, just because we hate looking at stuff without work. So make sure you show your work. No work means no credit. So here we go. We got 5 questions on the free response part. So here we go. Let's take a look at this guy. First question is this. Find the x-coordinate of the centroid of the region in the first quadrant bounded by the curves y equals 1 minus x squared, and below the x-axis you can use your calculator to evaluate your integral. But it's still showing your work. What were we looking for? How do we divvy up these points that we give out for this problem? Well, any kind of problem that they want area between the curves, or what's the volume of a rotated region, or a centroid problem, you should always graph your picture. You don't put a graph on there, you're going to lose some points. We want to see some pictures on this thing. What's my equation up here? The equation is y equals 1 minus x squared. So put my pen back in order here. There you go. What does y equals 1 minus x squared look like? So I'll blow this up, you guys can see this in the back here. All right, 1 minus x squared is a parabola upside down, but they did once again say first quadrant. So it'll be up here at 1 and it's a parabola upside down. It looks like this and also goes through 1 here. So this is the graph of y equals 1 minus x squared. It's bounded below by the x-axis. Here's my x-axis, so it's bounded below. Here's your y-axis. This will be 0. So we're talking about this region right here. We want to know, what's the question here? We want to know what is the x-coordinate of the centroid. So help me out here. What was the formula for the x-coordinate of a centroid? It was the moment about the y-axis divided by the mass. Just to remind you, what was the y-coordinate in case you wanted to know? It's the moment about the x-axis divided by the mass. So you understand, as I'm reviewing this thing, I'm trying to remind you of the formulas you're supposed to have memorized. All right? What is mass equal to? Mass is equal to density, which we call rho, density, times area. Well, if they gave me a nice little geometric shape, I can find the area of that thing by length times width or something like that. But because this is a function, area is going to be rho times integral of f of x top minus g of x bottom dx from a to b. So there's the formula for mass. What is the moment about the x-axis? That's the tendency to rotate around the x-axis. Again, this is for your benefit. This would be, the formula is rho over 2 times integral from a to b of your top function, f of x squared minus the bottom function, g of x squared dx. And the moment about the y-axis is going to be rho times integral from a to b of the point radius x times f of x top minus g of x bottom dx. And I'm doing this just to remind you of the formulas that you were supposed to know. Okay? But on this particular problem, all they wanted me to find was the x-coordinate. So the first thing I'm going to calculate is going to be the mass. Mass is going to be the rho, the density, times the integral between 0 and 1 of the top function, which is 1 minus x squared, minus the bottom function. The bottom function is the x-axis, which is the same thing as y equals 0, minus 0 dx. So this is equal to rho times, the integral of 1 is x, minus the integral of x squared is x cubed over 3, evaluated from 0 to 1. This is rho times 1 minus 1 cubed over 3. This is going to be rho times 1 minus a third. This is equal to 2 rho over 3, 2/3 rho. That's what I got for the mass. 2 rho over 3. Now the other thing that I need to calculate would be the moment about the y-axis for this example. Okay? The moment about the y-axis is rho times integral from 0 to 1 of x times the top function. I'm using this one right here, top function minus bottom function. The top function is 1 minus x squared minus the bottom function, which was 0 because it was the x-axis, dx. I'll slide it up so you guys can see this. I would clean this guy up. So this would be equal to rho times integral from 0 to 1 of x minus x cubed. Minus 0 is not going to matter, and I just distribute this x throughout. dx. This would be equal to rho times the integral of x is x squared over 2 minus the integral of x cubed is x to the 4th over 4, evaluated from 0 to 1. According to the fundamental theorems, plug in top minus plug in bottom. This would be rho times 1 squared over 2 minus 1 to the 4th over 4 minus rho times plug in 0, I get 0. So this ends up being rho times 1/2 minus 1/4. What's a half minus a fourth? A fourth. So I end up getting that 1/4 rho. So my moment about the y is 1/4 rho. Does that make sense? Bump, 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 bump. Therefore, your x coordinate to your centroid, which is your moment about the y divided by the mass, would be equal to 1/4 rho over 2/3 rho. What ends up happening to my rows here? They'll cancel out, so this is 1/4 times 3/2 when you clean it up. And I end up getting the x coordinate to be, what is this? 3/8. Or for you decimal fans, 0.375, whatever you want. Now, I know you guys are looking at this thing going, oh, geez, Dr. Taylor, you don't read directions real well. They said you can use your calculator to do this, all this integral stuff. And you're right. But as a professor, we went back to the guys who wrote the exam and complained about this. This was so easy. Why are you making them do a calculator to integrate this stuff? You should integrate this by hand. Setting you guys up for this next exam. So maybe you'll be integrating by hand a little more often than using the calculator. But every semester we get different unfortunate faculty members that have to make up this exam. So hopefully they'll probably put a few more integration by hand kind of problems on there. But don't forget, I don't care if I have to integrate it by hand or not. I'm going to sit there and double check all this stuff on my calculator. If my life depends on me doing real well on this exam, even though I have to show my work, I'll double check it on the calculator if I got calculator access to it. Don't forget to do that. Does that make sense? Questions? Did I lose you guys anywhere? All right. Next problem. So there's more points on the exam. Here's some more points on the exam. Let's find it. Find the volume of the solid formed by the region in the first quadrant, bounded above by the curve y equals sine of x, and bounded below by the x-axis on the interval between 0 is less than x, which is less than pi. Is revolved about the y-axis. Use your calculator to integrate this thing. All right. So, here we go. Let me blow this up a little bit so you guys can see this in the back. There you go. All right. What do I got here? I got a curve. Y equals the sine of x on the interval between 0 and pi. What does that look like? So always draw a picture. That's worth points. If you screw up all along the way, you'll at least get the points from the picture, maybe some points added on top of that. I'm showing you guys about how we grade this stuff. We look for certain aspects of this thing and try to figure out what the point totals are and stuff. And, you know, drawing pictures are at least worth 1 or 2 points, and that's more than you would have gotten if you didn't draw the picture. So, this is between 0 and pi. What does the sine graph look like? Well, the sine of 0 is 0. The sine of pi halves is actually 1, comes up here. The sine of pi is back to 0. So it's the first hump of your sine function. Yeah, I know it goes down and comes back up over here and does that, but I don't care. The fact is, they only care about between 0 and pi. So I graph that. And if you need to, you do have your calculator on the free response part of the test. That's the top region. The bottom is below by the x-axis. So here's my x-axis right here. So the x-axis is also known as y equals 0. So this is y equals the sine of x. So here's my region right here. Now, what do we want to do? We want to revolve this guy about the y-axis. So the axis of rotation is the y-axis. So we want to find the volume of this thing. Find the volume of the solid formed by taking the y equals sine of x on top, the x-axis on the bottom, and you're going to rotate around the y-axis. So understand this problem. My function is in terms of what variable right here? X. What axis do I want to rotate around? Y. What method do I have to use? Shell method. This is a shell method problem based upon the setup. Does that make sense? The function is in terms of x, but I'm going to rotate around the y-axis or something parallel to the y-axis. That's shell method. If the function is in terms of x, and I want to rotate around the x-axis or parallel to the x-axis, that's disk washer method. Does that make sense? This is a shell problem. Functions in terms of x, and I'm rotating around the y-axis. What is the shell formula? Volume is equal to 2 pi times integral from a to b of what I call the point radius times f of x top minus g of x bottom dx. So now let's put my numbers on this thing. So volume is going to be equal to 2 pi times the integral from 0 to pi, because this is my region here, from 0 to pi of the point radius. Well, point radius is an arbitrary point inside your region, and its distance between that point and the axis of rotation. My axis of rotation is the y-axis. Well, when you move away from the y-axis, it is an x distance. So this point radius would be just x, or officially x minus 0, if you want to actually calculate it out. Right minus left to get the point radius, x minus 0, which is x, times the top function, which is the sine of x, minus the bottom function, which is the x-axis, which is y equals 0, dx. I just want to show you guys me literally plugging stuff into the formula and seeing where all the integral parts come from. Let's clean this up. Volume is equal to 2 pi times integral from 0 to pi of x times the sine of x dx. All right, let's say this was a 12-point problem on the old exam there on the free response part. All right, right here is where you can get most of your points, because this is what we're looking for. Two things: setting up the integral in terms of these kind of word problems. This is where the majority of the points are going to come from. And then the rest of the points are integrating it. But what did they tell me on this one? Quote, use your calculator to evaluate it. So I don't actually have to integrate this thing. But what if I did? Again, preparing you for the test. What technique of integration would you use to integrate x times the sine of x dx is my question. Integration by parts. Recognize it. You've seen them before. You're going to see them again. Integration by parts. Integral of u dv equals uv minus integral of v du. In this problem, u would be x, dv would be the sine of x. Does that make sense? And you go through the rigmarole. But they did say, okay, fine. Integrate this thing here. And so I'm just going to integrate this on my handy dandy. But this is a trig function. Right here is where I saw probably about 20 students out of 2,000 last semester who actually screwed this problem up. Why? One thing. What mode should you be in? Radian. They were in degree mode. So they did all this beautiful work, and the wrong answer came off their calculator because they didn't pay attention. So here it is. Radian mode. Math number 9. Integral between 0 and pi of x sine of x dx. I got 3.141592654. Hey, you recognize that number? What number is that? Yeah, pretty much. Trig. Pi came out of this thing. So the volume would be equal to 2 pi times this guy is 3.1415926, whatever. You get pi out of it if you want to go decimals. So the real answer here was volume was equal to 2 pi squared units cube. Don't forget your units cube. It's a word problem here, and we're talking about volume. Or for those decimal fans, we also accepted, here we go, 2 pi squared, 19.739, whatever. So I wrote that down too as my answer for when we graded it. 19.7392088 units cube. And here's your answer. We don't give bonus points. Well, that's not true. Occasionally we see something so exciting, we'll give up one bonus point or something like that. So here's my little bonus point for you guys. What does this region look like that you just found the volume of? This 19.739 stuff. What does it look like? What the region looks like is you took this little hump right here between 0 and pi and the x-axis, and you rotated it around the y-axis. So you get the reverse image over here on the other side, right? And so this thing, and then you got it circular. So you've got to kind of envision this guy, so that freehand art ability for those good art students and stuff. This is what you got. I don't know exactly what this thing looks like. Little discs type thing here with the kind of scooped out in the middle of it. So that's what you found the volume of. 19.739 units cubed is how much stuff you got in it. Does that make sense? Questions? All right. Oh, yeah. This one killed a lot of students because they weren't paying attention to it. You know you're gonna put this kind of problem on the exam because we like it. We gotta pump some stuff out of a tank. They didn't draw a tank like we did on all the problems on class. No, they gave you some words, and you gotta draw it yourself. Here we go. A hemispherical tank, base of radius of 1 meter, sits with this base on the ground. The tank is full of water. Set up a definite integral that gives the work done in pumping all the water out of a tank at the top of the tank. The density of water is 1,000 kilograms per meter cubed, and gravitational constant is 9.8, officially meters per second squared. Should have given you that. Evaluate the definite integral by hand when you're done. All right, so there's basically two parts to this thing. Set up the integral, and then evaluate this thing by hand. All right, first things first, you got to draw it. First thing, okay, well, before I put my coordinate axes on here, let's draw it. It's a hemispherical tank. What's a hemisphere? It is half of a circle, right? This is what the tank looks like. The tank looks like this. It's a hemisphere with the base on the ground. And they said the radius of this thing is going to be 1. So if I put it on a coordinate axis, here's 0. The radius is 1. So it is 1 over here. It's 1 over -1 on this side. And it'll be 1 at the top. And your cross section to a hemispherical tank is going to be a semicircle. Think about it. But you kind of want to draw that 3D aspect in this thing here. So here's my picture right here. There's my hemispherical tank. Here's my y-axis. And the top of the tank is going to be at 1 because they said the radius of your hemisphere is 1. Now, here we go. We want to find the work in this guy. So, what does work equal to? What is my standard formula for work? Work is equal to the sum of your delta force times the distance that you got to pump. Where your delta force is equal to what we call water weight times your delta volume slice that you're going to take out of this guy. What is your water weight in this particular problem? Now, water or whatever liquid you have is always density times gravity in the metric system. This is a metric problem. If it was an English standard problem, we would have given you what the water weighs, 62.5 pounds per foot cubed. But remember, but you need to know your water constants here. 62.5 pounds per foot cubed in the English system. But what is it in the metric system? 9,800. It's 9.8, your gravitational constant times the density of water, which is 1,000. So the water weighs in this problem 9,800, that's official newtons per meter cubed, times your delta volume slice. So what is my delta volume slice going to be? So to calculate the delta volume, you got to envision this. This is where that scientific ability you guys have. This is an engineering problem. Delta volume slice. I'm going to come up here on my y-axis somewhere and take a little delta y slice. When I slice this thing, I'm going to cut it across here, but you got to envision it. Stop, pause, hesitate, and think. If I got a hemispherical tank and I take my little Ginsu knife and I chop it this way, right across of it, what's it going to look like? When I pull this little section out, because it was circular this way, it's going to look like a what? A little disc. Remember, it's very thin. Yeah, I know it's got a little slant on the side. Don't care about that yet. It's very, very thin. It's going to be delta y tall. And here's my question, but it's a disc. The volume of a disc is going to be pi r squared h. And remember, there's only two shapes you can get when you make this cross-sectional delta volume slice thing here. It's either going to be box shape or disc shape. Because this is a hemispherical tank, this is going to be disc shape. Does that make sense? What is the radius of a hemispherical tank here? What is the radius on this one? Because it's on the slant, you move away from the y-axis. What direction are you going into? You're going into x because it's on a slant. It's not 1. Up here somewhere is between 0 and 1 of radius. So the radius is actually going to be x. The height is delta y, so your delta volume slice is going to be pi x squared delta y in this problem. Yes, sir. You had a question?
Since it's hemispherical,
Yeah.
why is it 1/2 pi r squared? Because, the shape of the slice.
It's the shape of the slice, not the volume of the system. We're just doing the slice. And because it's a disk, it's a cylinder. Cylinder is pi r squared h. And so your boxes, your shapes are going to be either pi r squared h or length times width times height. And typically, if you do the length on this thing, it'll be like a 2x type thing here. Just reminding you of the problems we did in class. But this one is a disk, pi r squared h.
The radius is x.
Because it's on a slant. It's not consistent throughout the tank.
Okay.
All right? So, here it is. Delta volume is pi r squared delta y. So I'll put that over here. X squared, pi x squared delta y. So when I clean that up, my delta force is going to be 9,800 pi x squared delta y. So to get the work is equal to the sum of the delta force times the distance that you have to pump. And so this will be work equals the sum of your delta force, which is your 9,800 pi x squared times delta y, that's your delta force, times what is the distance that I actually have to pump this thing. Remember, this was at an arbitrary y level on this axis, and remember, work is all about lifting. That is why dy is always your natural axis here. Work is about lift. Where are we lifting this level y that we made the slice to? They said pump it to the top of the tank. Based upon my coordinate axis, where's the top of the tank at? 1. So what is the distance I have to pump this level to? Top minus bottom, 1 minus y. Does that make sense? This is at an arbitrary y level that you make the slice, and you try to figure out the distance from that arbitrary level, this is the variable part, y, to the top of the tank. And remember, distances are either top minus bottom or right minus left. We're lifting this thing, so it's top minus bottom, 1 minus y. So now, apply integral calculus to this thing, and you'll turn the problem into an integral. This will be 9,800 pi is a constant, comes up front. Summation turns into integration. This will be x squared times 1 minus y, and the delta y turns into the dy. So that sets up my integral. But I got a problem. You know what the problem is? Standard problem you'll see in most of these problems. Wrong variables. I got to integrate this thing with respect to y. What's sitting in the middle of my function here? X squared. So I need to convert this guy over. This is where you need to come up with the equation for edge of tank. Now, I had a hemispherical tank. When you look at a cross section of a hemispherical tank, what is it? The cross section is, in terms of the XY plane, is a semicircle, but it is a circle. What is the equation of a circle? And it's not just any circle, it is a circle centered at the origin. What is the equation of a circle centered at the origin? So I'll write that down. Circle centered at origin is always what? What is it? Very good. X squared plus y squared is equal to r squared. But what was the radius in this tank here? 1. So this will be x squared plus y squared equals 1. That means x squared would be equal to 1 minus y squared. That edge of the tank, when you find the equation of that guy, this is your linking variable equation. Basically your constraint type thing that your tank is under. So it's that linking variable equation that the equation for the edge of the tank is going to be x squared plus y squared equals 1 because it's a semicircle. When I solve that equation, I know typically we solve for x, but to plug it in, all I need is the x squared. So work is equal to 9,800 pi times integral of 1 minus y squared, sorry, there it is, 1 minus y squared, that's what x squared is, times 1 minus y dy. Now all I got to do now is, what's my bounds? Let's go back and look at the tank again. What are my bounds going to be for this problem? Where's the water that you want to pump this thing out? Quote unquote, it is full of water. Where's the water at? Between 0, the ground level, and the top of the tank, which is 1. So I'm going to integrate between 0 and 1. So there it is. This is probably out of the problem points, totals of like 10, this was worth 7 points. Okay, 6 or 7 points. But they ask you in this problem to do something or other. What did they ask you to do? You had to set it up and then evaluate the definite integral by hand. So there's two parts of this thing. That was setting it up. This is the equation that set it up. And it's just like all the other kind of problems we've done. Great problem to study. But I would also go back and look at your notes and see all the different types of tank structures that we had, just to review. But here we go. I got to integrate this thing by hand. How would you integrate this thing by hand? I personally, if I'm going to integrate this guy, I'm going to FOIL out this function inside here. So this will be W equals 9800 pi times integral, FOILing it out. 1 times 1 is 1. 1 times a minus y is a minus y. A negative y squared times a 1 is a minus y squared. And a negative y squared times a negative y is a plus y cubed dy from 0 to 1. This is the best way to integrate this guy when you've got a polynomial times a polynomial. FOIL it out. Then you got nice terms. Does that make sense? Now let's integrate this guy. This will be constant 9800 pi out front times integral of 1 is y minus integral of y is y squared over 2 minus integral of y squared is y cubed over 3 plus the integral of y cubed is y to the 4th over 4 evaluated from 0 to 1. According to the fundamental theorem of calculus, I shall plug in top minus plug in bottom. So work is equal to 9800 pi times 1 minus 1 squared over 2 minus 1 cubed over 3 plus 1 to the 4th over 4 minus 9800 pi times plugging in 0. You love it. You pretty much just get 0 there. 9800, but who cares? It's 0. That part goes away. So I am left with, when you take a half, see this is work is equal to 9800 pi times 1 minus a half minus a third plus a fourth. So I get 9800 pi times, I got 5/12 when I actually did that, when I added them together, which is equal to 4,083.3333 pi watt. Don't forget your units on this thing. It was worth a point. Nah, wrong, bang, crashed and burned. Minus 27 points for that one. What system are we in? Right, we're in the metric system. What is work? Because there's a meters thing here. What is work measured in the metric system? We would accept Newton meters or joules. This would be joules. Okay? I would take either one, Newton meters or joules. But if it was the English system, then it would have been foot pounds. But don't get them confused. We take off extra points for that. And or for those people that just love decimals, this is the same thing as 12,828.17 joules. We would accept either one. And of course, who am I kidding myself? Even though I showed all my beautiful math work by hand, I would go back to the original problem and just show you guys math number 9, integral from 0 to 1 of parentheses 1 minus x squared times parentheses 1 minus x, and then over arrow dx. Integrate this guy. I end up getting that. Multiply it times that 9800, and this is where I got my answer from. And it double checks, sticking a pi on it. And putting the pi on that answer, I would also accept this guy right here. I double checked it on my calculator just to make sure I didn't screw it up. Yeah.
So if the tank was half full, it would be, instead of 1 minus y, it would be 0.5 minus y?
No.
Or would it be?
No, you still got to lift it to the top of the tank. You can't deform your tank. The top of the tank's at 1. When you want to, quote unquote, pump half the water out of the tank, all right, your setup is exactly the same because the 1 represents the top of the tank minus y on this part right here. This is the lifting part, 1 minus y. What's going to change is your bounds. So all I worry about is my bounds. And assuming you mean half the water, meaning from 0 to a half because of the shape of the tank here. But now here's my question for you. What would you integrate over if you want to remove just half the water out of the tank? Well, do you remove the top half or the bottom half of the water? Top. So you would integrate from a half to 1 on the bounds. Does that make sense? From a half to 1. Yeah. Yeah. Yes. And then that would assume that the radius of the entire tank is 5. Absolutely. Absolutely. It's x squared plus y squared equals r squared. The r in this problem happened to be 1. If they change it to 5, change it to 5, fine. It's x squared plus y squared equals 5 squared, 25. That's fine. And then you solve for x squared, so x squared would be 25 minus y squared. And that would be the relation of the variable. And then the distance you would have had to pump would be 20. Oh, see, the top of the tank was at 5 now. It'd be 5 minus y. And your bounds would have been from 0 to 5 in that case. Yeah. Fundamental theorem of calculus says plug in top minus plug in bottom. If you know plugging in 0 is going to give you 0, then just chunk the 0 on that. That's not a problem here. But be careful. Weird functions like e to the 0 is 1, cosine of 0 is 1, stuff like that. Make sure you actually plug it in. But if, like this one's a polynomial, so when I plug in 0, I just get 0. But you should show me minus 0 just to let me know that you actually did that. Does that make sense? All right. You know at least one of the problems on the free response is going to come from the series section. Typically, it's going to be one of those manipulations of your Taylor/Maclaurin series. Why do we love power series? They're easy to manipulate. Take a look at this problem here. It says this. And this was awfully nice of them, but they don't have to give this one to you. Usually we make you memorize it. But I'm trying to help you out with the points here, so here we go. Use the expansion, which is one you should have memorized. This is the Maclaurin series for e to the x, which is 1 minus x plus x squared over, 1 plus x squared over 2 factorial plus x cubed over 3 factorial, ... So they want me to use this expansion to obtain a Maclaurin series expansion for e to the negative x squared. So here's, and again, what I'm trying to show you guys is why we love Maclaurin series or any kind of Taylor series, these power series, because they're easy to manipulate. We were given e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus ... They want e to the negative x squared. So what do I have to do? What's the relationship here? All I got to do is replace x with negative x squared. Does that make sense? So this would give me 1 plus negative x squared plus negative x squared over 2 factorial plus negative x squared cubed over 3 factorial plus ... Literally show them you plugging in for the x to do that they want you to plug in for. In this case, negative x squared. But then, be careful, you got to clean it up. Because they love this part A, part B stuff. You screw up one of the parts, it's going to kill you on the rest of the parts. So take your time. So e to the negative x squared would end up being 1 minus x squared. Negative squared is positive, that would be plus x squared would be x to the 4th over 2 factorial. Negative cubed is back to negative, power to a power and multiply. X squared cubed would be x to the 6th over 3 factorial plus ... This is my cleaned up version of the Maclaurin series for e to the negative x squared. They're easy to manipulate. Once you know one, that's why we want you to memorize those major 5s that we gave you, those major 5 formulas that we gave you in chapter 8.7. Now, they want you to approximate e to the negative 0.5 squared using the first 4 terms. Notice 1, 2, 3, 4. So I'm kind of eyeballing this thing and reading this problem, so I know that I need to write out 4 terms. If they said 5 terms, I think I can catch a pattern. The 5th term would have been what? X to the 8th over 4 factorial. Does that make sense? Catch a pattern on this stuff. But they said just 4 terms, and that's 4 terms there. So, but now, the deal is this. If you look at this, e to the negative x squared, now remember, I got this. E to the negative x squared is equal to 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial plus ... Using just the first 4 terms, I want e to the negative 0.5 squared. Does that make sense? The question is very simply, what's x going to be that I'm going to plug in? The negative matches up, x squared. This is negative 0.5 squared. So what's x? Careful, you died. This is e to the negative x squared. They want e to the negative 0.5 squared. What is the x? The negatives match up, the squares match up. What does x have to be? Don't screw that up. Don't plug in the wrong number. X has got to be 0.5 you're going to be plugging in. Does that make sense? Check out the pattern here. So when I plug in the 0.5, I'm going to get 1 minus 0.5 squared plus 0.5 to the 4th over 2 factorial minus 0.5 to the 6th over 3 factorial plus dot, dot, dot. Okay? And clearly I'm going to put this on the old calculator here. This will be 1 minus 0.5 squared plus 0.5 to the 4th over 2 factorial. That's 2 times 1, which is 2, minus 0.5 to the 6th over 3 factorial. 3 times 2 times 1, well, that's 3 factorial is 6. And that would be equal to, when I plug it in, and I got 0.778645833. Okay, just putting it on my calculator. So when I actually plug this thing in, this is what I got. Now, this, the Maclaurin series for this guy is supposed to approximate this. So the last thing I'm going to do, now this is going to be close, but I'm just going to do this just to make sure I'm in the right track. Negative 0.5 squared, and what do I get? I got 0.7788 something or other. I only used 4 terms, so it'll be close but not exact, but I'm feeling real good about my answer. It should be the same thing as the function, or it's basically squiggly equal to, because this is approximate. Does that make sense? Double check your answers to make sure. Now, the next one is part C. This series, because that plugging in that negative, is an alternating series. So use the alternating series estimation theorem to give an upper bound on the error on your terms in part B. Just to remind you of the alternating series estimation theorem, it says the remainder for n terms, which is equal to the true sum minus the partial sum of n terms, is always less than or equal to b n plus 1. Okay? So when you're putting out n terms, the next term up is where your error is going to be at. All right, but then that's what I want to know. From part B, what is the next term up? Okay, so what is your bn plus 1? Remember, with the 4 terms. And we just discovered this a few seconds ago. What would it be? What's your next term up? See, we're going, let's take a look at it. It is it's 1 minus 0.5 squared plus 0.5 to the 4th over 2 factorial minus 0.5 to the 6th over 3 factorial. What would the next term up be? What would it be right here? It would be 0.5 to the what? 8 over 4 factorial. That would have been my next term up. So the error, Rn, which is the true sum minus your partial sum, would be less than or equal to 0.5 to the 8 over 4 factorial. So I put that on the old handy dandy calculator just to remind you how to do that. This will be 0.5, close parentheses, raised to the 8th power, divided by 4 factorial. You hit 4, and then underneath your math key right here, under math, these factorials are in the probability factorial. You could do 4 factorial in your head. 4 times 3 times 2 times 1 is 24. But I'm just trying to show you some cool stuff on the calculator here. And so I end up getting this. I end up getting 1.627604167 E negative 4. What does E negative 4 mean to you guys? Times 10 to the negative 4th, which means I'm going to move this decimal place 4 places to the left. That'll be 0.0001627604167. There is my error. Does that make sense? Questions? All right. One more problem, but of course, it's got 2 parts. Yes? Sometimes we specify, but when we don't, and you're using your calculator, give them all to us. Okay? That's always a good rule of thumb. Always give them all to us. That way, there's no question about it. All right, here we go. Last problem, number 5. Part A and Part B. What does Part A say? It says use the midpoint rule with n equals 4 subintervals to approximate the integral between 0 and 1 of 1 over x plus 1 dx. Okay? You must show work in both parts of this particular problem here. Okay, so here we go. I'm trying to approximate this with the midpoint rule. So my function, f of x, is equal to 1 over x plus 1. Okay? My bounds are between 0 and 1. So a is 0, b is 1. They gave me n equals 4. So the first thing I'm going to do is calculate my delta x. What does delta x equal to? What's the formula you have memorized? B minus a over n. This will be 1 minus 0 divided by 4, or 1/4. Okay? And remind yourself, write down the formula. You writing down formula, if you screw up anything else in your calculations, writing down the formula will at least get you some partial credit out of it. What is the Riemann sum formula for the midpoint? It is the sum of f of x, I with a little borrowed for the midpoints, times delta x. Don't forget to make sure you have memorized left Riemann sum, right Riemann sum formula, the midpoint Riemann sum formula, the trapezoidal rule formula. Remember that one? That was delta x divided by 2 times, parentheses, f of a plus 2 times f of x1 plus 2 times f of x2 plus plus 2 times f of xn minus 1 plus f of b, close parentheses. And the Simpson's rule Riemann sum formula. Simpson's rule. Delta x divided by 3 times f of a plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3 plus 2 times f of x4 plus plus 4 times f of xn minus 1 plus f of b. The 4-2-4 combination, right? I know I got a program waiting for this problem. I'm going to nail this problem, but I got to show my work. So you've got to have the formulas memorized. You throwing an answer on this thing without the work, we take extra points out for that crap. Show us the work, all right? So here's my formula, and what I'm going to do here is I like to draw out a number line because I want to make sure I hit my points here. So a is 0. Delta x is 1/4. So I move over a fourth, that gives me a fourth. I move over another fourth, that's going to give me a half. I move over another fourth, that's going to give me 3/4. I move over another fourth, and that gives me 1. A to B, and I got 1, 2, 3, 4 partitions. So I partitioned this thing out. So I want to see where my endpoints are at. 0, a fourth, a half, 3/4, and 1. But this is the midpoint. What is the number between 0 and a fourth? What is it? 1/8. What is the number between 1/4 and 1/2? 3/8. What's the number between 1/2 and 3/4? Catch a pattern. 5/8. And what's between 3/4 and 1? 7/8. How do I get a midpoint? I add the two endpoints together and divide by 2. Add the two endpoints together and divide by 2. Add the two endpoints together and divide by 2. Add the two endpoints together and divide by 2. That's how I'm getting on, but I can do this stuff in my head. They're just basic fractions. Does that make sense? These are my guys. So here we go. The midpoint for 4 partitions is going to be my delta x times f of x1 midpoint plus f of x2 midpoint plus f of x3 midpoint plus f of x4 midpoint. What is your delta x in this problem? I just rewrote this a long way. The delta x is 1/4 times f of your first midpoint, which is 1/8, plus f of your second midpoint, which is 3/8, plus f of your third midpoint, which is 5/8, plus f of your fourth midpoint, which is f of 7/8. Okay? What was my function in this problem? Again, to remind you, finally going to get to use it, it's 1 over x plus 1. Not the integral of it. You use the guy that you're trying to approximate this integral. If I integrate it, yeah, I know it's the natural log of x plus 1, and I was amazed how many people actually used natural log of x plus 1 to plug this stuff in, and you screwed up. You're not supposed to integrate the function. You're supposed to use the function you're going to integrate and use this technique to approximate the integral. Does that make sense? The function is what you're integrating, not the actual integral of it. That was a common mistake on this problem. So this is equal to 1/4 times 1 over 1/8 plus 1 plus 1 over 3/8 plus 1 plus 1 over 5/8 plus 1 plus 1 over 7/8 plus 1 when I plugged in these functions, these numbers into my function. So at this point, Who am I kidding myself? It's all about punching numbers on the calculator. And when I put this number on my calculator, I got this. 0.691218912. Does that make sense? Well, how many decimals should I go? They didn't specify. Give them all to me. And then the last thing I'm going to do on this particular problem is this. They gave me a function doing a left, right, midpoint, trapezoid, a Riemann sum on it. I want to remind you of your program. I'm going to go y equals, clear out the old stuff that I typed in before. This is 1 divided by, don't forget the parentheses, x plus 1. Just type in the function under y equals. Second quit, I'm going to go to program that I have my program ready to go. Riemann sum. What was my A? It was 0. What was my B? It was 1. What was the number of partitions I needed? 4. And don't forget, if I'm doing Simpson's rule in the calculator, the program doubles the n. So if I want a Simpson's rule for n equals 4, I plug in n equals 2, because the program is going to double it. Does that make sense? So, and then I hit enter, and it gives them all to me. The left, the right, the midpoint, the trapezoid, and the Simpson's rule for 8 partitions is down there. Well, we wanted the midpoint. 0.691219891. Yeah, pretty much I got my answer. I got my points off this problem. Does that make sense? Now, the second part. It says this. If the second derivative of x is less than or equal to k, absolute value of the second derivative of x is less than or equal to k, for a is less than or equal to x, for less than b, and e is the error when you use the midpoint rule with n equals n subintervals, use it to approximate the integral from a to b of f of x dx. Then error e is less than or equal to k times b minus a cubed over, and they have a typo on the test. This was the midpoint rule. The trapezoidal rule is when you divide by 12. What do you divide by for the midpoint rule? Yeah, so let's fix that, because I had to go during the exam and go around and fix this one, because that was a typo, because somebody typed in the trapezoid formula. The midpoint formula is divided by 24n squared. Make sure you know your error-bound formulas for midpoint, trapezoid, and Simpson's rule. Okay? Midpoint is k times b minus a cubed over 24n squared. Trapezoid is k times b minus a cubed over 12n squared. And Simpson's rule was what? K times b minus a to the 5th over 180 n to the 4th. You remember? Where k was the maximum value of the 4th derivative. They were nice. They only wanted the second derivative. Okay, so here we go, because this is the midpoint rule. All right. So the first thing we got to do this problem, and there's where the big point goes, was could you find k? So it's the maximum value of the second derivative. Remember, my function was 1 over x plus 1. Also known as x plus 1 to the negative 1. I need the second derivative. So this is Calc 1 stuff here. The second derivative, f prime of x would be equal to chain rule. Derivative the outside 1, x minus x plus 1 to the subtract 1, negative 2, times derivative inside, which is 1. This is negative 1 times x plus 1 to the negative 2. Your second derivative is going to be negative 2 times negative 1, which is 2. Times x plus 1, 2, subtract 1, negative 3, times derivative inside, which is 1, which is equal to, when you clean it up, 2 over x plus 1 cubed. Because this was the midpoint rule, we just needed the second derivative of this guy. Now remember, we're trying to find the maximum value over my interval. My interval is between 0 and 1. So I'm going to graph this thing on my calculator. So go to y equals, clear it out. And I'm going to graph the second derivative. This is 2 divided by parentheses x plus 1 cubed. And all I care about is graphing it between 0 and 1. And I'm going to do a zoom fit on this thing, zoom 0. And this is what the graph looks like. And I'm going to go back and change the window slightly so you can actually see it a little better. Y minimum, let's make it like negative 1 to 2. This is what the graph looks like. And I'm going to graph it down here. Between 0 and 1, you got up here, it comes up here and does this. Between 0 and 1. Where is the maximum value occurring at? You can clearly see from the graph. The maximum value is this is your second derivative here, and it's the farthest distance away from the x-axis. What point is the farthest distance in your range of points between 0 and 1? It's the point at 0. So your k would have to be the second derivative at 0, absolute value, but it's going to be positive. So when I plug in 0 into this thing, this will be 2 over 0 plus 1 cubed, which makes it 2 divided by 1, which is 2. And there's the big points right there, because could you figure out what k is? K has got to be 2 in this problem. It's the maximum value of the second derivative. So I took the second derivative and I graphed it and I figured out the point that had the farthest distance away, and I plugged that point into my second derivative to figure out what the k value is. The k value is up here at 2. Now I'm going to plug this into my formula. So now I got this. Absolute value of E would be less than or equal to k times b minus a cubed over 24n squared. Now using all the parts from part A here, the error would be less than or equal to, you had to get the k right, that was your big points, 2 times b, which was 1, minus a, which is 0 cubed, divided by 24 times n. What was n in this problem? Go back and look at it if you forgot. What was n equal to? 4 squared. Okay? So, and then I actually put this on my calculator. The absolute value of error would be less than or equal to, and here we go, 2 times 1 minus 0 cubed. Who cares about that? That's just pretty much 2. Divided by, just don't forget, parentheses around the denominator. 24 times 4 squared, and close parentheses for the denominator. And this is what I get. 0.0052083333. Does that make sense? Questions? Yeah. K is the second derivative for the error bound formulas for the trapezoidal rule and the midpoint rule. For the Simpson's rule, K is the maximum value of the fourth derivative. And the formula changes. It's k times b minus a to the fifth power divided by 180 into the fourth. Make sure you know your formulas and stuff. Other questions? Yes, ma'am. Why did I use 0 to get my k value? When I graphed the second derivative, which was 2 over x plus 1 cubed there, when I graphed this function, k is the maximum value of the second derivative. So maximum value means the farthest distance away from 0, absolute value. So it's either positive or negative here. But at 0, this is the farthest distance out of all the points along your second derivative. This guy has the farthest distance away, so your k value would occur at the 0 point. And so I plugged 0 into my second derivative to figure out what the k is. Yes, you're actually comparing it. The y-axis is your second derivative, and it's the furthest point away from the x-axis of the second derivative. And when it's the Simpson's rule, it would be the fourth derivative of this. Right. Other questions on this thing? Yes, question.
So if the graph was mirrored, it would be 1?
Yes. And if the graph was like this, then it would maybe at a half or something like this. I would plug that point into a half. And usually they occur at the endpoints. I'll give you that. 9 times out of 10, they're going to occur at the endpoints. But if you got one that occurs in the middle, well, then you can use the maximum function on your calculator to get that what that k value is. But hopefully they'll be nice in terms of these kind of numbers we're trying to put on the final exam. Other question? Yeah.
On the first part, since you've done the rule, are you going to put units on that answer?
What's that now?
Are you going to put units on the answer?
No. Well, this one, they didn't say anything about calculate the area. If they said calculate the volume or calculate the area or given the feet per second, what was the distance, that would be in feet. Either they have to give me units, but if they ask me for area, that would be traditional units squared. If they ask for a question that has a distance and they didn't actually put the units on there like feet or miles or whatever, or meters, you put just units. And if they ask you a volume of problem, we typically put units cubed to denote the fact that we have a volume here. No, that's the whole idea is an integral gives you the quote-unquote area in a curve. That's your geometric representation. But the only time I actually quote-unquote put units on it, if they ask what is the area, they'll throw area in the question, or the word volume in the question, or the word distance in the question. Then I'm going to be paying attention to units because that's more of a word problem thing. This was just use midpoint rule. That's all they said. Does that make sense? Other questions? Don't let this be the only exam you guys study. We got lots of them on there. I've done this every semester, so get online, get one of my students, because I gave them several old exams with the videos that correspond to these things. Make sure you study multiple exams because there's a lot more formulas out there. This is what they did last semester. Last thing here. How would you guys have done on this particular exam? What do you think you would have done? Very well, good, poor, not real sure. What you think? All right? You know what the class average was? 65. Class average on this exam was a 65. Careless error on a lot of it killed their grades. 65, not that bad. It's a little lower than what the math department would have liked. They weren't totally disappointed, but they were hoping it would be a lot better than that. But careless errors on the multiple choice sections and careless errors on the free response, like this problem. A lot of people integrated this thing and then tried to use the midpoint formula on the integral form. No, you use the original function on that. Little careless errors on them like that. The other big one was, let's see here. This one, people get confused because it's series at the end here. But the other big one that people screwed up was this one. They didn't know where to start. You know where you start on a tank problem that you got to pump all the water out of? You draw a picture. Try to get and then get a feel for the problem. Always draw a picture. If you don't draw a picture, you're already lost on this problem and you'll never get it right. You got to draw a picture and then you got to put your coordinates on there. It's little things that if you get it wrong right from the beginning, they end up losing big points. Don't leave anything blank. You guys know some of them. Yeah.
We have the kind of first hour is no calculator.
First hour is no calculator, and then after that, you'll be left with part 2 and part 3. You get calculator the rest of the time. All right. Study hard, and I'll see you guys for my class tomorrow at 3 o'clock. And by the way, where's my exam at? Macinary 125. All right. See you guys then.